Hello there, and welcome to the Sleepy Science Channel. Tonight, we drift into one of the oldest, most mesmerizing forces on Earth, fire. It's both destroyer and creator, warmth and chaos, the original influencer of human evolution. Long before cities, before words like hot or bright, fire was already whispering in the dark, lighting up our fears, and cooking our first questionable meals. It has danced in our myths, powered our machines, and burned in the hearts of both gods and poets. Fire is not a thing, it's a transformation, a living border between what was and what will be. It moves like thought, consumes like time, and glows with the same restless energy that fuels the stars above us. The same physics that turns a log into ash is the one keeping the sun on fire. If you enjoy these quiet journeys through wonder and science, take a second to like, subscribe, or drop a thought below. It helps others find their way here too, one sleepy, curious mind at a time. For now, just breathe, let your eyes grow heavy, let the gentle light of fire warm your thoughts. Tonight, we learn how matter dreams in color. Fire is chemistry caught in motion, a visible chain reaction racing faster than you can blink. It's not a single thing but a process, an endless relay between fuel and oxygen. Molecules meet, break apart, and reunite in a furious dance. Every spark gives birth to the next, and that cascade is what we call flame. What looks like a steady glow is actually millions of tiny chemical events happening every second, each one a microscopic miracle. As bonds shatter and electrons rearrange, energy spills out as heat and light, turning invisible motion into something you can feel on your skin. The flame trembles because the air itself is alive, shifting, swirling, teasing the balance between life and extinction. Too little oxygen and it suffocates. Too much and it flares in a last desperate blaze. A candle's calm flicker and a wildfire's raging inferno are two verses of the same elemental poem. Fire is the visible handwriting of energy matter transforming itself before your eyes, showing how the universe keeps its rhythm through destruction and renewal. So, the next time you stare into a campfire, remember you're not just watching heat. You're witnessing stardust, remembering what it means to burn. In the dance of combustion, between the cool air and the fiery inferno, exists a boundary so delicate it's like walking a tightrope made of atoms. Here, under the intense heat, molecules put on a spectacular show of destruction and rebirth. At an astounding speed, they swap bonds like a game of molecular hot potato, shooting out tiny particles that glow and quickly fade away. It's chemistry with a flair for the dramatic. The color of a flame is like nature's mood ring, changing hues based on temperature and what elements it's feasting on. You might witness blues, radiant yellows, or even blinding white heat, all contorted in mesmerizing shapes. This dance is all about balance. Convection lifts hot air up like a cozy elevator while fresh oxygen rushes in from below. Right in this heated zone, we witness matter's grand exit as it releases energy, morphing invisibility into dazzling visibility. Look closely, and you'll see that combustion isn't some magic trick where things puff away. Rather, it's a thrilling transformation. As things burn, they don't simply vanish. No, they're just shedding their layers, merging with oxygen, generating brand spanking new molecules like carbon dioxide and water vapor. The energy that once held them together bursts forth as heat, sound, and light talk about a fiery release. Every time molecules link arms to react, they spark a chain reaction, a microscopic relay race promoting energy transfer. It's like a never-ending game of tag that keeps going until our fuel party finally runs dry. What's left behind? Just the ash, the stubborn leftovers of material that refuse to dance in this chemical gala. And let's face it, this ash has seen better days. As flames croon their fiery lullaby, chemistry steps out from backstage, flashing its brilliance. The secrets of the universe unfold in vivid color, showcasing the restless nature of matter itself. The very same principles illuminating your cozy candle afterwards fuel the mighty engines of our world and forge the wild landscapes we adore. Each flicker of heat is a small but mighty act of creation, an ongoing cosmic dance of rearranging reality. Color me fascinated. The flame's hue whispers secrets about what's being consumed in its fervid embrace. When a substance ignites, its atoms spill energy in specific amounts, determining the vibrant colors we feast our eyes on. For instance, a little sodium will bless you with a bright yellow display, while copper dazzles in greens or blues and strontium brings the drama with deep crimson. But what's really happening behind the scenes? It's all about electrons taking their own leaps between energy levels, letting go of energy in the form of beautiful photons as they settle back down. The radiant spectrum from a flame acts like a trusty fingerprint, allowing scientists to peer into the elemental makeup of materials, all thanks to their unique colors. Who knew fire could be such a revealing artist? In the dazzling display of fireworks, science transforms into art as metal salts dance on the sky, each color carefully curated to spark joy. Take a candle flame. It may look humble, but it hides a spectrum of colors within. Down at the base, the blue signifies perfection, where combustion is spot on. Meanwhile, the glorious yellow glow above is all about carbon particles doing their best impersonation of bright stars before they evaporate into the ether. It's really an atomic party, where energy is offered, then dances away just as quickly. Now, let's zoom in on the star of the show, the wick. It's not just hanging around, it's busy as a beaver in this little universe. The hottest party is just above it, where the vaporized wax is mixing with oxygen like they're old friends. We're talking about a sizzling temperature that can scorch over 1000 degrees Celsius. Below, that lower blue edge means complete combustion is in full swing, while those charming yellows and oranges are the cooler particles having their last hurrah. The wick stays cool, like the last kid picked on a playground, mostly unburned, thanks to the wax flowing upward, keeping the flame's attention. But don't be fooled, the candle flame has attitude, and if things get off balance, say, due to a lack of oxygen, it flickers and smokes like a diva throwing a tantrum. Ideally, it creates a lovely teardrop shape, a mini engine of chemistry converting wax into carbon dioxide, water vapor, and a symphony of light. The warmth we feel is just energy feeling liberated, eager to waltz through the air and hug our hands with its glow. Enter the blue flame. Oh boy, now this is the high achiever. It represents the ideal combination of fuel and oxygen, no leftover carbon cozies up here. These flames shine with pure thermal energy, vibrating with higher energy photons, tossing out way more energy per collision. They burn twice as hot as their orange companions and are a testament to efficiency done right. You'll find this blue brilliance at gas stoves and torches, where the air supply is just so, ready to create consistent heat. Conversely, the orange flames are like the free-spirited artists of the flame world, bearing witness to incomplete combustion. They glow thanks to those stubborn soot particles, emitting light at lower temperatures. They may not have the same precision, but their vibrant display has its own charm, showcasing the carbon that blue flames have devoured. It's a visual representation of inefficiency and artistry. A beautiful balance of light and warmth, painting a unique picture. In the end, while both blue and orange flames have their own personalities, they're bound by the same chemistry, whether burning hot and bright with efficiency or radiating a softer, whimsical glow. These flames tell timeless stories. They remind us that even in something as simple as a candle or a gas stove, there's a wild, vibrant dance of atoms happening all around us, lighting up the world, one flicker at a time. Brew fire is little more than a marvel wrapped in an enigma. It burns cleanly and fiercely, leaving behind a trail of heat, light, and that sneaky, invisible gas we often forget about. Imagine flames that can caress your skin without leaving a mark. How wild is that? Some folks might think that all flames are out for a scorched earth policy. But oh boy, are they in for a surprise, when conditions are just right. Like when you mix alcohol with a side of limited oxygen, you can get flames that glow a devilish blue and stay cool enough to touch, at least for a fleeting moment. These cold flames might look like they've forgotten how to raise their temperatures, but they've got a lot going on beneath that mellow facade. They slowly release energy, like an introvert finally deciding to open up. No fiery outbursts here. Scientists are all over these chill flames, using them to crack the code behind combustion, explosion prevention, and even engine knocks. Who knew that within the world of fire, there lurked such a fascinating spectrum, from gentle flickers to plasma level rage at its core, whether sizzling hot or delightfully cool. Fire is all about atoms exchanging energy through chemical reactions. What makes fire such a rebellious little gem is its ability to thrive in various gases if the stars, or rather, the reactants, align just right. Oxygen plays the leading role in our bonfire tales. But it's not the only gas with a thirst for combustion drama. From the flamboyant fluorine to the charismatic chlorine, each gas can spark a fireworks show if the right fuel is part of the mix. It's all about balance, a meticulous dance of reactants where even a small misstep can lead to a tragic flame out or an explosive overindulgence. In the cornucopia of science labs, some research warriors have brought forth flames swathed in atmospheres like hydrogen fluoride or pure chlorine. Talk about living on the edge. These bizarre blazes boast colors that range from vibrant green and violet to nearly invisible flames that might leave you scratching your head. They reveal an exciting truth that combustion isn't confined to our cozy air, but is a universal language of chemistry looking for any opportunity to express itself. What fire consumes, it doesn't just eat, it masterfully transforms into entirely different substances. Watching this process is akin to witnessing a magic show where the magician not only pulls a rabbit out of a hat, but also turns it into a dazzling bouquet of flowers. Burn a piece of paper, and don't just expect ashes to tumble down, know that the very essence of that paper is morphing into gases, heat, and a twist of light, crafting a new reality from the old. So the next time you see fire flickering, think beyond the flames, engage your inner chemist and imagine the shenanigans happening at an atomic level. Remember that behind those dazzling flames, there's a whole universe of mysterious chemistry, transforming materials and illuminating the shadowy corners of scientific inquiry. The world of fire is an exhilarating one, full of stories of transformation and energy dancing just beneath the surface. It's a fiery reminder that chaos and creation can go hand in hand, and each flicker could lead to a new discovery waiting to ignite. Burning is an incredible spectacle, a dazzling process that turns wood into a fiery dance of transformation. When it ignites, the cellulose in the wood does a little disappearing act, morphing into gases, ash, and charcoal while hydrocarbons join forces with oxygen. This lively reaction produces energy and gives birth to carbon dioxide and water vapor. That flickering flame, it's not just eye candy, but the very evidence that change is in full swing. What's left behind after a bonfire might look like ashes, but you can bet there's a riveting tale beneath that soot. Each speck of ash is just a remnant of its former self, redefined by the heat as it transforms into simpler forms. Even those little minerals are just the rearranged leftovers of what once was a solid piece of wood. When fire comes knocking, nothing escapes unscathed, everything merely shifts into new arrangements, with atoms doing a grand tango. The crackle of burning wood is at a concert in the flames. Yes, indeed, every piece of wood, even those you'd swear were as dry as a desert, has its secrets held within tiny pockets of water. When fire works its magic, it heats these hidden droplets until they burst forth as steam, creating little explosions of sound. Each pop is like the wood cheering on its own transformation, with sap and gases adding delightful sound effects to the fiery performance. As the wood sizzles away, it becomes a fuel factory, emitting volatile gases that are the fiery equivalent of a party invitation. These gases keep the flames dancing and crackling, captivating our ears while that magical rhythm unfolds. It's like nature's own symphony as moisture, heat, and release conduct a delicate balance, a last hurrah for a living substance, offering warmth, light, and its final earthy whispers. But let's not forget those little stars called sparks. When they fly off from a fire or a grinder, it's not just a show of lights, it's a metallic moment of rapid oxidation. Each spark is a tiny, glowing particle that gets so heated it lights up for a brief second before vaporizing, making it a fleeting spectacle. PF energetic magic. In a heartbeat, they're gone, leaving us spellbound and hungry for more of nature's wild performance. So, the next time you find yourself around a fire, take a moment to soak it all in. It's not just wood split from trees. It's a chaotic, gorgeous transformation where structures burn to release their energy in playful bursts. Each crack, pop, and spark tells a story of change where matter becomes warmth, light, and an orchestra of sounds, serenading us with the alchemy of burning. When a tiny particle bravely ventures out of the main flame, it doesn't just stroll away casually. It becomes the star of its own dramatic show. The oxygen in the air jumps in, attacking the particle's surface, culminating in a fiery mini-explosion. This reaction cranks up the heat to astonishing levels, often beyond the melting point of steel. It's like a tiny firework display, with every flicker marking the atoms shedding electrons and forming shiny oxides. In the grand world of pyrotechnics, sparks aren't just lucked upon, they're meticulously engineered. Fireworks artists select their metals with precision, opting for iron, titanium, and aluminum, each bringing its own unique color and burn time to the party. They're like an orchestra of elements, each playing its part to create an unforgettable visual symphony. And even those seemingly random sparks flying up from your campfire embody the same science, delightfully chaotic yet governed by rules. As sparks take flight, they reveal a deeper truth about flames. Each little piece of fuel sailing into the air completes its own mini combustion cycle, making it a microcosm of the larger fire. It's a fleeting transformation, a split-second eruption of energy, brevity lending it an exquisite charm. Just visualize it. A little speck of light breaking away, leaving a spectacular trail of brilliance like a comet in the night sky. Now, let's chat about that intriguing shimmer you see dancing above flames. It's not just a fancy light show. Oh no, friend, it's air putting on a performance. As heat rises, it alters the gas's density, causing light to bend like a contortionist. The warm air makes molecules spread out, resulting in layers that change how light behaves. This bending can create illusions like a sizzling road that appears to glisten after a long day. Delving into the realm of scientific inquiry, researchers employ lasers in labs to decode these shimmering visuals. It's astonishing that what seems like a mere halo of movement is a language of convection, revealing hidden temperature gradients in motion and light. It's as if the air waves its hands frantically, signaling temperature changes to the curious eyes of scientists hoping to unlock its secrets. Flames have a life of their own and are far from static. They flicker and dance because the air swirling around reshapes them constantly. Think of a flame as a moving artwork, a fluid dance of chemistry and oxygen. When hot gases escape upward, they make way, inviting cooler air to dive in, stirring things up and keeping the fire lively with fresh oxygen, leading to a flame that's anything but predictable. Little adjustments in the surrounding air can significantly influence how heat spreads and how quickly molecules get busy colliding. Every tiny breeze can send a ripple through the flame, altering its form and intensity. It's a wild dance of elements competing for attention, where even the slightest gust can send sparks soaring higher as flames sway to the rhythm of their environment. So the next time you gaze into a flickering fire, remember, it's a vibrant spectacle of science at play. In a world of sealed chambers or microgravity, flames take on a perfectly spherical persona, swirling steady like a little planet. But toss that fire into the open air, and it's a whole different ballgame. Enter convection currents, the mischievous breath of nature that keeps flames flirting, flickering, and dancing like they're auditioning for a spotlight on Broadway. Every flicker is like fire's way of saying, "Challenge accepted," as it navigates the atmosphere around it. Let's peek inside a candle flame, shall we? Picture glowing carbon particles flaunting their stuff before they do the vanishing act. It all begins when wax heats up and reacts with oxygen, breaking down into carbon and hydrogen. The hydrogen has its moment, burning away cleanly to create heat and water vapor. Meanwhile, the carbon decides to stick around a bit longer, forming those charming little soot particles that get heated until they glow. That's the source of the magical yellow light that makes candlelit dinners feel oh so romantic. And here's the kicker, that warm glow isn't from fire alone. It's more like a farewell party for the carbon particles. As they soar through the flame, they glow brightly, embracing their fate before merging into the air and leaving just a whiff of ash behind. The candle flame orchestrates a vibrant show of colors, ranging from a deep blue at the base where the magic of complete combustion happens to the golden top where particles glisten and wink goodbye. Each moment is a mesmerizing dance of destruction and creation. Did you ever wonder why flames morph and bend? It all boils down to the speed of the air around them. In stillness, hot gases rise in a straight arrow, crafting that iconic teardrop shape we all recognize. But throw in a breeze, and suddenly, the flames are stretching, twisting, or doing a little side shimmy as they adapt to the new airflow. It's like they're saying, "Bring it on," as they chase the warm air upwards while inviting the cooler air below to step in. Oh, and don't forget when things get a bit wild, turbulent airflow turns that modest flame into a chaotic masterpiece. One moment it's a serene flicker, and the next, it's chaos as it twists, waves, and reshapes into unexpected forms. This chaotic beauty isn't just eye candy. Engineers and scientists scrutinize these mesmerizing shapes to crack the code of combustion efficiency. Each curve and flicker holds the key to how heat and oxygen get along, revealing secrets in their dance. So the next time you light a candle, watch closely. you're witnessing a stunning transformation fueled by chemistry and physics, with each flicker telling a story of survival in an ever-changing atmosphere. Fire, it turns out, is not just a source of light and warmth, it's a lively, dynamic artist, painting the air with its flames, from the teardrop shape to glowing carbon. Each element of a candle flame is a playful reminder of nature's creativity at work. In the absence of gravity, fire transforms into a perfectly round blob, a delightful dance of chemistry and physics reminiscent of a cosmic gymnastic routine. Instead of reaching skyward, flames float fancifully in space, serenely sculpted by the gentle nudges of diffused gases. It's a fiery marvel, a visual reminder that in the universe, there's no up or down, only playful chemistry molding motion into artful flames. But wait, fire isn't just a pretty sight. It's a chatty little entity. Every flicker, crackle, or explosive burst makes its own unique soundtrack, like nature's own DJ spinning beats. This is because, as gases rapidly expand, they create sound waves that ripple through the air. Whether it's the comforting pops of a campfire or the booming growl of a furnace, every fiery sound is simply a melody composed of pressure waves, showcasing fire's hidden vocal talents. Well, let's not ignore the big fires, shall we? These burning beasts can whip up vibrations so robust that they generate low, resonant tones, affectionately dubbed fire wells or combustion oscillations. Scientists, modern-day fire whisperers, dive into studying these sounds, especially to ensure all systems are stable in engines or rockets. In this fiery opera, even the soft hum of a lone candle participates, sounding off in a more subdued register. Who knew a flame could carry such a rich and variée tonale palette? Speaking of magnificent wonders, fire also pulls off an astounding feat of conductivity, dancing into the realm of plasma. At elevated temperatures, flames set atoms aglow, liberating electrons moving in a whimsical zigzag through the gas. This creates plasma, that elusive fourth state of matter, half fluid, half electrical wizard. While the flames of a humble fire might not cut through steel, they nonetheless demonstrate an electrifying capability that hints at the stellar power of the sun. A deep connection exists between chemistry and physics through that flickering flame, forming a vibrant bridge where matter and energy intermingle. Its plasma core softly conducts current through the air, creating an intricate web of light and movement. Picture it as a lazy river of charged particles flowing alongside each burning molecule, representing a delightful relationship between elements. Talk about a happening social scene. However, fire's behavior takes on yet another twist depending on gravitational conditions. Picture it, gravity pulls on those hot gases, determining how they swirl and twirls with every flick of heat. A fire's character shifts like a chameleon, adapting to whatever gravitational environment it finds itself in, making it clear that even flames have their preferences. So, from candlelight dinners to starry night bonfires, every blaze tells a unique story dictated by the gravity of its circumstances. Let's take a moment to appreciate the cleverness of it all. Fire is not just a source of heat or light, it's a consummate entertainer, a remarkable scientist, and an electrifying artist. In its playful twists and turns, it teaches us about the universe's beauty and complexity. Who knew that something as simple as a flame could weave together a tapestry of sound, electricity, and chemistry? Next time you gaze into a flame, remember, you're witnessing a dazzling display of nature at its most whimsical. On Earth, we're all too familiar with flickering flames, as gravity pulls cooler air downward while the lighter, hotter gases rise. It's a beautiful dance of fire that warms our homes, cooks our food, and offers cozy ambience. However, take that gravity away, and you have a whole different ball game. On the Moon or Mars, flames ditch their flickering flare, growing wider and dimmer. An uninspired cosmic flame leaves us wondering, where's the sizzle? In weaker gravity environments, combustion becomes a game of diffusion rather than the lively convection we know and love. Instead of the usual upward hot air dance, the molecules slowly mix around like they're at a boring party. The result? Flames on other celestial bodies seem plump and lazy, spreading out instead of shooting up. If you thought our earthly fires were something special, wait until you see what they look like in orbit. In the magnificent weightlessness of space, flames switch gears and transform into perfect glowing spheres. Yes, spherical flames. They glow evenly in all directions, totally free from the flicker we associate with terrestrial fire. It's like they've finally got the Zen vibe they've always wanted, burning more efficiently and slowly while consuming fuel with the utmost dignity. Who knew space globes could be so elegant? Astronauts aboard the International Space Station have been lucky enough to witness these floating spheres firsthand. Imagine floating stars. The lack of turbulence means that the chaotic nature of fire is nowhere to be found. Instead, they behold calm flames, an otherworldly superhero of chemistry manifesting in serene spherical forms. Who knew fire could be so chill while still doing its job? What's even wilder is that fire has a secret in pure oxygen atmospheres. In a setting where oxygen reigns supreme, combustion becomes so efficient that flames can lose their visible glow. They may look like invisible phantoms. But don't let that fool you. This process can set temperatures soaring. All the energy released is primarily heat and ultraviolet radiation, leaving the orange and yellow sparks behind like a high-flying magician. Without unburned carbon particles or incomplete reactions creating that fiery punch, these flames are the ultimate in fresh, clean burning. They become nearly invisible manifestations of energy, showcasing a behind-the-scenes level of efficiency. Imagine a realm where fire doesn't need to show off all while maintaining its impressive abilities. So, the next time you cozy up to a flickering flame on Earth, remember the cosmic counterparts that float serenely in the silence of space. These celestial fireballs remind us that even the most cherished experiences can look radically different framed by the absence of gravity. Gravity's pull shapes our experience in ways we often take for granted, even affecting how something as commonplace as fire behaves. Whereas Earth flames have personality, their interstellar cousins take on a visionary charm among the stars, basking in the absence of chaos yet still radiating warmth and energy. Risky business. Fire has a knack for playing hide and seek in oxygen-rich environments, where it sneaks in, consuming materials faster than you can say hot potato. Researchers aren't taking any chances here. They conduct their fiery experiments with the safety levels cranked up high. Because let's face it, all it takes is a tiny spark, and boom, you've got an explosion. When fire gets too perfect, it turns into a stealthy little thing, leaving behind nothing but silent reactions, hinting at how close it can flit away into the invisible realm. Now, here's a fun fact. Some metals have a talent for burning hotter than molten rock. Surprising, right? We usually think of fuels as the typical wood or oil, but metals like magnesium, titanium, and aluminum can put on quite a fiery show. Once they get hot enough, they ignite into dazzling white or blue flames, shooting up temperatures that can vaporize granite. Once the ignition switch gets flipped, good luck stopping the reaction. It's a relentless dance with oxygen, forging stable oxides, and unleashing a spectacular energy burst. In certain controlled environments like welding and pyrotechnics, this fiery intensity is all fun and games. But when things go south in industrial settings, it can turn chaotic, melting through containers, floors, you name it. And here's the kicker. Some metal fires don't even mind getting wet. Yes, underwater shenanigans allow these fiery elements to continue their hot streak by using their own stored energy. It's a fiery reminder that combustion isn't just for wood or oil, it's an elemental phenomenon binding the universe together. Speaking of wild elements, enter lightning, nature's own glass-blowing maestro. When lightning strikes sandy soil, the flash can hit a temperature hotter than the sun's surface, over 30,000 degrees Celsius. In that wild instant, the grains of silica melt together and crystallize into delicate tubes of glass called fulgurites. These shimmering structures capture the electrifying dance of lightning as it zips through the ground, leaving a unique imprint that can stretch meters deep. It's a small miracle, a testament to a fleeting moment that lasts mere seconds but is forever etched in nature's canvas. Each fulgurite tells its own story, a memoir etched in glass that preserves the very path of lightning, giving us a glimpse into the secrets of natural energies. These fragile masterpieces reveal that nature has a flair for the dramatic, blending chaos and beauty into a compact piece of art. The intricacies lie in their unique shapes, which can only be crafted by wild flashes of energy that seem almost magical, connecting the terrestrial with the ethereal. It's moments like these that remind us of the wild beauty of our planet and the astonishing ways it transforms in the blink of an eye. From the invisible dance of perfect combustion to the explosive brilliance of burning metals, it's a grand showcase of nature's own fire show. Each discovery feeds our curiosity, stirring excitement as we uncover the fiery secrets hidden within matter. So next time you catch a lightning strike or a metal spark, remember the stories they tell and the wild dance of energy at play. Scientists have a wild obsession with lightning, not only for its unpredictable power but also for its stunning results. Treasure hunting collectors view the glassy remnants known as fulgurites as nature's very own artwork, crafted in mere milliseconds. Imagine this, a bolt of lightning so intense that it transforms mundane sand into dazzling glass, a feat that most craftsmen struggle to replicate in the comfort of their studios. Nature really knows how to get the job done, doesn't it? When lightning strikes, it's like nature unleashes a mini explosion, heating the air to an incredible intensity. The core of a lightning bolt tips the scales at a jaw-dropping 30,000 degrees Celsius, making the sun's surface temperature of 6,000 seem like a pleasant day at the beach. As this electrical energy bolts through the sky, it essentially plays a brutal game of atomic whack-a-mole, liberating electrons from their cozy atoms and turning them into plasma. With each strike, it's a fine example of chemistry gone wild. And then there's the thunder, the dramatic soundtrack to all this electrifying action. The rapid expansion of the superheated air creates a shock wave that resonates across the sky, announcing the lightning's dramatic presence. It's less than a second of brilliance, yet that piercing flash leaves behind a path of glowing plasma while the surrounding air collapses in its wake, echoing with a thunderclap that makes your heart skip a beat. Talk about a natural spectacle. Nonetheless, lightning isn't the only place where fire plays tricks. Underwater flames can dazzle, too. Special chemical reactions allow flames to burn even while submerged, thanks to the clever combination of compounds that release their own oxygen. Imagine that a fire that refuses to be stifled by water, chlorine and fluorine join forces with metals like magnesium and lithium, creating a hot party in aquatic depths. Who knew chemistry could throw such a fiery bash? These underwater pyrotechnics are not just a science experiment gone rogue, they actually have practical applications. Naval engineers are all over these fiery marvels, harnessing them for everything from emergency flares to underwater welding. Forget about oxygen from the air. In this watery world, the reactions just need the right fuel and oxidizer to keep the flames alive and kicking. It's a dance of elements that turns our notion of fire upside down. So, as lightning illustrates the immense electric energy in the sky, these underwater flames remind us that combustion isn't limited to dry land. The world of chemistry proves that all it takes is the right mix and conditions, and fire can truly appear anywhere. It's a glorious show of nature's diversity, showcasing an unfathomable energy exchange that exceeds our wildest imaginations, right whether above or below the waves. Nature, you clever fire starter. Beneath the shimmering waves of the ocean, matter dances in mysterious ways, sometimes flaring up with dazzling brilliance. Take white phosphorus. For instance, this curious substance is like the artist of the chemical world, spontaneously igniting and sketching fiery patterns at room temperature. Its molecules are clustered in a precarious configuration, eager to mingle with oxygen. When they do, they perform a spectacular light show, glowing briefly before bursting into an eye-popping flame. And boy, does it deliver a smoke show too, transforming into dense white phosphorus pentoxide. Now, storing this fiery little diva is no easy feat. If you ever happen to acquire some white phosphorus, make sure it's tucked safely underwater or nestled in an inert gas, or else it might just decide to throw a surprise party. It's famous for its roles in flares and tracer ammunition, but beware its volatility can make it hazardous. Yet even while chilling in the shadows, it can offer a soft, greenish glow called chemiluminescence. All in all, white phosphorus is the double-edged sword of chemistry, proving that just the whiff of air can lead to a chemical tantrum. On a completely different note, let's jet off to Indonesia, where volcanoes don't simply erupt, they put on a light show. On the slopes of Kawaregan, burning sulfur bursts forth, showcasing a surreal electric blue glow as it flows alongside molten rock. It is a spectacle that could steal the spotlight in any magical tale. By day, this breathtaking blue fire is a no-show, but as night falls, it transforms the landscape into a fiery wonderland, igniting when it meets oxygen at blistering temperatures that would make even the bravest adventurers sweat. The experience of watching these flaming rivers of blue is genuinely like something out of a dream, almost eerie in its beauty. Lucky miners who labored nearby gathered up solid sulfur while treading carefully among the glowing streams. Just imagine strolling along with that captivating sight all around you. It's proof that the Earth can concoct mesmerizing wonders from simple elements when they're heated to their breaking point. This unique display of combustion from the Earth's depths is one of nature's most haunting spectacles, a reminder that energy can transform in the most unexpected and dazzling ways. The volcanic heat acting on sulfur demonstrates a brilliant chemistry that brings out the vibrancy hidden in mundane substances. One can only marvel at how these chemical reactions create stunning visuals, like a painter splashing color across a canvas. And for those inclined to look up, meteor trails are a celestial continuation of this infernal artistry. Imagine tiny fireballs streaking across the atmosphere, like nature's own fireworks show. Each burning fragment offers a brief glimpse of the chaotic energy that hyped the formation of our universe. These astronomical bursts bring to mind the captivating phenomena created right here on Earth, showcasing a harmony of reactions, combustion, and light in a symphony of cosmic and terrestrial birth. Whether it's the flickering glow of white phosphorus below sea level or the ethereal fire lighting up volcanic slopes, the world is replete with explosive surprises waiting to ignite our imaginations. So next time you're by the ocean or gazing at a mountain, remember the hidden powers waiting just below the surface and above in the skies, ready to captivate anyone curious enough to look. As a meteoroid plunges into Earth's atmosphere, it gets hot, like really hot. Friction with those pesky air molecules heats it up to thousands of degrees. This rapid energy surge causes the meteoroid surface to vaporize, creating a breathtaking glowing trail of plasma and molten particles. The dazzling streak racing across the night sky that we affectionately call a shooting star is just a brief fireworks show in space, lasting only a split second before it bids adieu. Larger meteors, however, tend to put on a much more dramatic performance. They transform into brilliant fireballs that don't just vanish, they leave behind glowing ionized trails. Talk about fashion statements. The colors of these celestial fireworks are as varied as a rainbow, depending on what elements they contain. Magnesium glows white, sodium sparks yellow, and nickel lights up green. It's like Mother Nature's way of throwing a color party up there. The cool thing is, while most meteors disintegrate upon entry, some brave souls actually survive the journey and land on Earth as meteorites. These remnants serve as a delightful reminder that even in the upper atmosphere, where things seem calm, fire can ignite when cosmic speed meets our planet's air. It makes you wonder, who needs fireworks when the universe can put on such a show? Speaking of fire, let's talk about wildfires, those ferocious beasts of the natural world. Picture this. They can move faster than a human who's just seen their ex at a party. Driven by wind, steep slopes, and usually a feast of dry vegetation, wildfires can race forward at jaw-dropping speeds. In extreme situations, they can top 20 kilometers an hour. Imagine the race. The flames are already preheating and igniting fuel ahead of them, almost like they're preparing a hot meal as they go. But that's not all. Chunks of burning embers carried by the wind can spark new fires kilometers away, making everything feel like a chaotic game of whack-a-mole. The sound of a raging wildfire, it's like a symphony of combustions, where millions of tiny fires come together to create one massive, thunderous roar. Scientists are constantly on the lookout, using models and satellite data to forecast where these fiery monsters will go next, all in a bid to keep our communities safe. Despite the threats wildfires pose, they aren't just nature's way of throwing a wrench in our plans. Surprisingly, they play important ecological roles, cleaning out old growth and replenishing nutrients in the soil. The sheer scale of their chemistry is astonishing, unleashing power into the air while the wind dances around, aiding and abetting destruction in a dramatic display of nature's raw force. And now, for the pièce de résistance, fire tornadoes. Yes, you heard that right. When conditions are just right, a wildfire or an industrial blaze can stir up a swirling column of air and flames that towers higher than most city buildings. As the heat skyrockets, the surrounding cooler air rushes in, creating a fiery vortex that could dance hundreds of meters into the sky. These fire devils can move unpredictably, swirling like they're the headliners in a demonic carnival. Talk about wanting to avoid the front row seats. Imagine a fiery inferno where temperatures soar beyond 1,000 degrees Celsius and winds whip around like nature's wildest amusement park ride. Far fiercer than any hurricane, welcome to the world of fire tornadoes. These rare, almost mythical whirlwinds don't just spin for show. They can yank debris from the earth and launch it into the skies, spreading embers across great distances, despite their chaotic appearance. They're all about physics formed from convection and rotation, but cranked to the max by heat. When the elements collide in such a fiery fashion, the atmosphere becomes an artist, crafting magnificent columns of flames that stretch high into the sky. But watch out, when hurricane-force winds kick in, the flames realize they're on a giant trampoline, tipping sideways and skimming along the ground like a living ribbon. This peculiar behavior transforms our usual notion of fire, which loves to leap skyward, into something that literally crawls across the landscape, driven by sheer wind force. Even a torrential downpour isn't enough to stop these rampaging flames if the heat is sizzling hot enough. Firefighters have their work cut out for them because unlike your typical fire, this sideways phenomenon grabs hold of new fuel sources like a hungry beast, igniting everything in its path. Understanding how this crazed dance of heat and motion plays out is critical for predicting just how far the fire will spread. The sight is nothing short of mesmerizing, more raw magic than mere flames, showing us how two elemental forces can reshape each other under the wildest of conditions. Oh, but wait, it gets wilder. Firestorms can generate their own thunderclouds and even play host to lightning. Picture it, under the grip of an intense wildfire. The rising heat creates colossal plumes of air that mimic volcanic eruptions. As those hot gases rise, they cool and build towering clouds known as pyrocumulonimbus. Inside these tumultuous clouds, particles of ash and ice bump around, generating electrical charges, much like you'd find in regular thunderstorms. Suddenly, crackling bolts of lightning zip across the sky, lighting up the world below, sometimes even sparking new fires miles away. The winds are in a frenzy, swirling like dancers around a bonfire as they rush in to fill the space left by the rising hot air. They essentially invite even more oxygen into the blaze, making it burn even brighter and fiercer. What's more, these self-sustaining monsters can whip up winds surpassing even the most fearsome hurricanes. Just when you thought things couldn't heat up any further, temperatures can climb to rival those found within a volcano. It's an elemental ballet where heat, wind, and fire join forces, creating spectacles that are equal parts or inspiring and terrifying. Nature, it seems, can put on a show that leaves even the bravest firefighters feeling utterly humbled. Fire is a drama queen of the natural world, flaring up and demanding the attention of the atmosphere. This blazing diva not only creates smoke and embers but also sparks off dramatic weather events. Rain, hail, and lightning are among its fabulous offspring, conjured straight from the heat that dances high into the sky. Imagine witnessing a firestorm, where the heat rises, swirling up like a dramatic speech, commanding the weather to spin into action. Speaking of dramatic, let's talk temperatures. The hottest flames on Earth are no wimpy sparks. They can exceed a jaw-dropping 3,000 degrees Celsius. Just when you thought you'd seen it all, controlled fires crank up the heat even more. With a mix of acetylene and pure oxygen, you can achieve fiery temperatures that are hot enough to melt steel, turning iron into liquid goo and vaporizing glass faster than you can say hot potato. And if you think that's impressive, you haven't seen the wackiness of chemical reactions like burning magnesium or thermite concoctions. These produce dazzling, eye-searing flames that can tear through metal, glowing bright white like 1,000 suns. These incredible flaming reactions are home to the thrilling world of industrial manufacturing, where precision and power go head-to-head in a feverish competition. Now picture flames reaching such intense heat that matter transforms into a dynamic dance of electrons and ions. With everything around shimmering violently, molecules are torn apart like a heated family argument. It's a spectacle where danger meets artistry, revealing the electrifying limits of chemistry, where flames flirt with plasma in a radiant performance that lights up the stage of science. Delve deeper, and we find ourselves amidst laboratory plasmas that take heat to cosmic levels. Here, scientists are channeling their inner stars, creating bursts of plasma soaring into the millions of degrees. In fusion experiments, hydrogen atoms huddle closely, fusing to make helium while releasing an awe-inspiring amount of energy, akin to a toddler's explosive tantrum over candy. The plasma glimmers in vibrant blues and purples, as if it's auditioning for a sci-fi movie, with electrons zipping about wildly through this electrically charged gas. Despite its fiery nature, The energy stays contained in a compact space, thank goodness for safety. This sizzling hot experimentation gives us a glimpse into the forces that power our universe and has the potential to unlock the secrets to limitless clean energy. So, while fire might gleam and glow, its true magic lies in its dramatic ability to shape our weather, fuel industry, and even lead us toward a brighter future. Who knew that such a seemingly simple element could hold the keys to understanding the cosmos and perhaps, one day, transforming how we power our lives? Fire's unpredictability might just be the spark we need for a revolutionary change. Inside these blazing chambers, the heat and light paint a vibrant picture, reminding us that fire, at its hottest, shares traits with starlight. It's a fiery dance where matter transforms into pure energy, mimicking the chaotic beauty of the universe's infancy. You can practically feel the intensity radiating as fire melts stone into glimmering glassy surfaces that gleam like extraterrestrial rocks. Mother Nature has a knack for crafting masterpieces from sheer heat, turning rocks into smooth, shiny glass like a cosmic artist with a blowtorch. Ever seen what happens when lava graces the landscape of sand or stone, or when a lightning bolt hits the ground? The intense temperatures from both scenarios melt minerals, fusing them into lustrous layers that capture the imagination. This fascinating process, known as vitrification, locks in gas bubbles and streaks of ash, almost like a glassy time capsule. Take a trip to ancient hill forts in Scotland or Ireland, and you can observe walls that have melted together, living witnesses to the fierce heat of battles or spiritual ceremonies. In laboratory settings that feel like something out of a sci-fi movie, scientists crank up the heat above 1,500 degrees Celsius, recreating those wild, fiery effects. What emerges is black glass that holds a poignant history. Each shimmering piece has a tale to tell about how solid matter transformed into a liquid due to scorching temperatures that redefined the very landscape. There's something inspiring about fire's knack for softening Earth's toughest materials, proving that even granite can bow down to its intense heat. And then there's the wild world of molten metal fires. Imagine trying to douse one of these beasts with water. Make sure you have a fireproof cape on. Metal types like magnesium or sodium decide that water isn't just a foe, but an unexpected ally that accelerates their fiery rampage. Instead of snuffing out the flames, the water shatters into hydrogen and oxygen ingredients that feed these outrageous fires. The explosive reaction sends molten droplets flying, turning firefighters into acrobats as they leap to smother the blaze. In industrial realms where molten metal reigns supreme, the stakes are high. These infernos pose a unique challenge as they have the disastrous potential to melt through floors and machinery, leaving chaos in their wake. Even the tough as nails concrete can't withstand that brutal heat, cracking and vaporizing like a bad magic trick. Clearly, this fiery phenomenon isn't just a surface spectacle, it dives deep into the molecular party, reshaping materials right down to the atomic core. But beware, in the wrong conditions, water becomes an unwilling accomplice, enhancing the chaos instead of quelling it. Picture aluminum dust swirling through the air. It's a recipe for explosive ignition that can turn a quiet industrial setting into a horror movie. Who knew something so seemingly harmless could lead to such a fiery frenzy? The elemental dance between fire, water, and metal plays out like an action scene from a blockbuster, showing us the powerhouse drama that unfolds when the heat turns up. Powdered aluminum is a mischievous little thing. Suspended in the air, it turns the atmosphere into a silent fuel tank just waiting for a spark to say hello. Each microscopic flake is like a tiny matchbox with an enormous appetite for oxygen. The moment ignition happens, the reaction doesn't politely begin, it detonates, unleashing shock waves, heat, and a lesson in chemistry's explosive enthusiasm. This shimmering chaos is known as a dust explosion. It's not limited to metals. Even humble substances like flour or coal can stage their own pyrotechnic show. Imagine a bakery turning into a rocket test site because of airborne pastry dust. Factories know this all too well, which is why they install ventilation systems and grounding wires like nervous parents baby-proofing their homes against sparks. In aluminum plants, the line between normal work and catastrophe is thin as smoke. One rogue electrical spark or a careless frictional touch can transform the room into a furnace of pure destruction. The real villain isn't just chemistry, it's geometry. When particles are tiny enough, air itself becomes the fuel, turning the ordinary into the terrifyingly combustible. In that instant, the boundary between solid and flame vanishes. What was once metal dust now becomes a storm of fire racing through air that didn't know it could burn. It's like watching matter forget the rules. Heat replaces shape, and everything glows with furious beauty before collapsing into silence and ash. Gasoline plays a similar game, but with style. The liquid itself is calm, deceptively harmless until it starts to evaporate. Then it releases invisible vapors that mix with air in perfect, dangerous harmony. All it takes is a flirtatious spark from static electricity, maybe from your sweater or a sliding nozzle, and boom, the chemistry of combustion takes center stage. That's why fuel stations look so paranoid about grounding. Every metallic pipe, every nozzle, every warning sign is there to stop a spark smaller than a mosquito's sneeze. The energy needed to ignite gasoline vapor is so minuscule that it feels unfair, like nature's version of a prank that ends with a fireball. Once lit, gasoline doesn't just burn, it performs. The flame races through the vapor cloud in an instant, then dives back into the liquid like it's feeding on itself. The more it burns, the more vapor it creates, sustaining its own chaos in a loop of brilliant destruction. It's beautiful in the most horrifying way. The hidden moral here is unsettling. Danger doesn't always roar, it whispers. Fire isn't born from grand gestures, but from tiny, invisible moments where vapor and energy shake hands. A single spark, a single breath of the right mixture, and suddenly the calm becomes catastrophe. Even ice can join the act. Under the right chemical spell, snow can burn, proving that fire isn't loyal to warmth. Substances like sodium or potassium react with water so violently that they create both heat and hydrogen gas, a duet of flame in the middle of the cold. The frozen world, it turns out, is only pretending to be safe. So, whether it's powdered aluminum or frozen sodium, chemistry reminds us of a simple truth. The line between calm and chaos is thinner than smoke. Invisible forces lurk in the air, waiting for a spark, a thought, or a careless moment to set the world aglow. When the chemistry of snow and ice meets the right elements, an unexpected phenomenon occurs. You might think that ice is a party pooper for flames, but guess again. Certain chemicals can react with these frozen surfaces, generating enough heat to set hydrogen ablaze. It's like having a tiny bonfire in winter. This scientific magic shows us that it's not all about temperature but the energy stored in those chemical bonds. You break them, and poof, heat and light. Imagine a scene where snow glows with fiery colors instead of lying dormant. While summer bonfires crackle and pop, winter shows off a different performance, one where flame can thrive even in the chilliest settings. It's a mind-boggling concept. While we usually think cold spells are the end of all warmth, chemistry throws a curveball, letting flames sprout bravely from the icy ground. A frosty facade belies the truth. Energy knows no seasonal limits. You might be thinking, why does fire sometimes look greener? Enter copper. When copper or its salts are thrown into the mix, these elements send their electrons dancing up to higher energy levels. As they come crashing back down, they release light. Hooray! The result, a vibrant emerald hue that contrasts dramatically with the typical yellows and oranges of flames. It's like adding a dash of spring to an otherwise wintry palette, reminiscent of spectacular green fireworks lighting up the night sky. Copper is a superstar in labs too. When compounds containing copper are heated, those eye-catching colors return, perfect for demonstrations on the inner workings of elements. Vivid glows showcase how atomic structure betrays its secrets, revealing a colorful fingerprint, which delights scientists and onlookers alike. Each green flicker translates invisible atomic energy into a visual treat, reminding us that the microscopic world is often more thrilling than it initially seems. But before you think fire is always visible and vibrant, let's chat about those sneaky alcohol flames. Some alcohols like methanol and ethanol burn with a performance that we might entirely miss in bright sunlight. Their flames are practically invisible, revealing only a hidden heat that goes unnoticed. It's like a magician's trick, leaving you in or without ever seeing the act. It's eerie and fascinating, and also highlights how cleanly they combust, producing mainly carbon dioxide and water. This invisible fire phenomenon presents a double-edged sword. While it makes alcohol useful in a lab for experiments requiring stealthy flames, it can also spell trouble, especially when it comes to racing fuels. You could be near a blazing inferno and not even know it until the heat hits you like a surprise hug. This sneaky characteristic really emphasizes the dual nature of science. It can be a tool or a trickster, depending on how you wield it. So, From burning snows to bright green flames, the dance of chemistry reveals the wonders of heat and light. Each reaction is a little story of how elements interact, creating spectacles that are often unexpected in the coldest conditions. If you find yourself out in winter wonderland, remember the playful chemistry hiding beneath its icy cover, waiting to surprise you, no matter how low the temperatures drop. The mysterious invisible flame, recognizable only by its sneaky heat and a faint blue shimmer in the dark, often plays hide and seek with firefighters and chemists. These brave souls utilize thermal cameras and ultraviolet sensors to unearth the ghostly fires lurking just beneath the surface. The combustion is so pure it feels almost ethereal, whispering that not all flames love to flaunt their fiery presence. Sometimes, the most vigorous flames are the ones we can't see, adding an element of surprise to the wildfire game. Wildfires got their start long before majestic trees graced the earth. Picture a time when lightning bolts were the original troublemakers, igniting primitive plants and algae mats on land. These early wildfires were like nature's first clean-up crews, munching through low vegetation while belching out gases that played a crucial role in adjusting oxygen and carbon dioxide levels. Fossilized charcoal, dating back almost 500 million years, stands as a testament to these fiery beginnings. Who knew that ancient burns would one day provide some serious clues to our planet's history? As trees began to evolve and tooled up with their woody stature, the wildfire cycle cranked into overdrive. Suddenly, all this would become prime tender, and with rising oxygen levels, it triggered massive blazes that raged through ancient landscapes. Fire had been on Earth long before the forests themselves, interacting and evolving with the life forms that would come to share its domain. Wildfire acted as a fiery sculptor, shaping ecosystems and forcing species to develop the resilience to dodge or bounce back from its flames. Long before humans wielded matches or lighters, nature had established lightning as its original flamethrower. Each electrifying bolt carried a staggering voltage, turning trees, grasslands, and dry peat into battlegrounds of fiery transformation. With every strike, landscapes dramatically shifted, releasing nutrients back into the soil and making room for fresh growth. Animals, either playing the game of dodgeball or adapting their skills, learned to navigate the fiery chaos, while plants cultivated traits that allowed them to not just survive but thrive amid the flames. The atmosphere back then was like an unhinged party, buzzing with reactive gases that made ignition a regular feature of life. Some brainy scientists propose that these spectacular natural fires actually helped sculpt Earth's chemical landscape, producing vital compounds that were stepping stones for the development of life itself. Lightning didn't just spark flames, it catalyzed a larger process that intertwined elements, crafting a foundation for biological diversity. Every time lightning strikes today, it resurrects that ancient cosmic theater, reminding us of its role in knitting together the sky with Earth through flames. It stands as living proof of nature's radical ability to ignite transformation. As if performing a dramatic duet, fire brings together the raw power of the heavens and the earthy embrace of our planet, illustrating the balance between destruction and creation that has been playing out for eons. Embrace your inner wild after all. The Dance of Flames is a wild story penned by nature herself. Long before our ancestors learned how to conjure fire from nothing, they were masters at keeping embers singing and glowing. Imagine early humans, those clever little survivalists, covering hot coals with ash or lugging around smoldering sticks like trophies from their conquests. These portable infernos provided warmth on chill nights and a cooking method that whispered sweet nothings to their bellies. Forget dining out, this was the original meal prepping. The archaeological digs have confirmed what we all suspect: keeping fires alive was as vital as finding food in the wild. When it comes to mastering fire, our ancestors were like savvy little wizards, while striking sparks from rocks or rubbing sticks together came later. Being able to nurture an ember was a revolutionary breakthrough. Each glowing coal represented hope and warmth, a metaphorical seed of civilization carried safely into the great unknown. Imagine each ember as a tiny miracle, a pocket of life that enabled early humans to migrate, explore, and dominate their surroundings with confidence and flair. About 2 million years ago, humans were cooking up a storm with fire, and the remains in ancient caves give us the tantalizing details. Archaeological evidence from Africa reveals charred bones alongside ash layers, suggesting that early humans were not just lucky, they were hungry and downright genius. The change from raw to cooked food was monumental. It softened the meat, broke down plant fibers, and let loose a trove of nutrients. Move over. Raw diet. Our ancestors were becoming brainiacs, thanks to their new culinary skills. And let's talk about the artistry of fire. Those evidence-packed caves didn't just tell a story of clumsy accidents. They spoke of meticulous fire keeping. The same spots were repeatedly heated, proving that this glowing gift was more than a hazard. It was a clever tool wielded with intention. Fire took on a new role, becoming both a companion and a guide. Let's be honest. Who wouldn't want a trusty torch that could change the darkness into an invitation for bonding, creativity, and spirited storytelling? Speaking of storytelling, fire turned night into a canvas. Before its warm embrace, darkness meant it was time to kick back and hibernate. Who could blame our ancestors? But with fire lighting up the shadows, human activity exploded into a vibrant nightlife full of cooking concoctions and dramatic tales. Work and leisure blended together as communities formed bonds over flickering flames. Crafting, gathering, and laughing night became a stage for ingenuity and connection. And humans never looked back. As those early flames flickered in caves, they didn't just illuminate rooms, they cast illuminating shadows on human destiny. We see echoes of this ancient dance in our kitchens and homes today, from the simple candle flicker to the warm glow of a family dinner. It's all rooted in that primordial spark. The legacy of fire is a living pulse, connecting us to our ancestry while making sure our dinner parties never lack a little drama. In every meal shared and every story told around the firelight, we honor the incredible journey of our species and the warmth that forever fuels our evolution. The flickering of torches and campfires was more than just a source of light. It was the heartbeat of early communities. These glowing beacons created social spaces where people gathered, bonded, and kicked off cultures creatively. Shadows on cave walls danced and inspired art, turning simple gatherings into theatrical productions. The warmth of the fire didn't just send shivers away, it guarded against lurking predators ready to crash the party. And let's be honest, who wants a lion dropping in uninvited? As generations passed, fire transformed into more than mere survival, a symbol of knowledge and spirit. It illuminated the night, extending the hours for thought and creativity. Those quiet reflections by the fire transitioned into the sparks of human progress. It was during the dark, when the light met the mind, that innovations ignited and dreams began to take flight. Flickering flames were not just cozy. They were the essence of inspiration and imagination for our ancestors. In the wild, campfires built a literal barrier of safety, like a superhero's shield against the dark. The warm circle of light signaled stay out to creatures that roamed the night, while the scent of smoke kept pesky bugs at bay. Early humans huddled close, confident that nothing would dance across the threshold of flame. Archaeologists loved digging up fossilized hearths. Showcasing fire was more than warmth, it was life's first line of defense. A fort of flickering hope. Within this enticing circle, humanity didn't just find safety but also a platform for creativity and cooperation. With every crackle and pop of the fire, dreams flourished into tools, stories, and music. The campfire became a stage for early minds to stretch, where imagination could evolve freely. Fire awakened the urge to communicate, providing a cozy backdrop for those legendary early storytellers to weave tales that still echo today. Imagine nights filled with warm, glowing flames while people exchanged stories, laughter, and perhaps a few ghost tales. 2. Flames danced in hypnotic rhythms, guiding gestures that mirrored their movements. Anthropologists theorize that the campfire circle marked the birth of classrooms, an arena where elders became the first teachers, sharing life lessons through spoken word. Knowledge didn't just survive, it thrived within the embrace of flickering light. From those flames emerged a tapestry of language, weaving sounds into deep meanings. The interplay of voices, shadows, and emotions helped turn storytelling into a rich art form. Through every myth that flickered and echoed, civilizations took shape. The power of the campfire made language less of a puzzle and more of a shared experience, strengthening bonds through time. The legacy spun from those embers continues to burn brightly in cultures around the world. Around the flickering glow of ancient campfires, a delightful alchemy was brewing, not just words, but dreams, hopes, and the kind of tall tales that could make a woolly mammoth chuckle. Have you ever noticed how, even today, gathering around a fire evokes camaraderie? This bond between storytelling and fire runs deep, sparking creativity that counters the darkness. Who would have thought that a good old fire pit could ignite everything from ghost stories to gourmet marshmallows? In a glorious twist of fate, early humans stumbled upon some funky rocks, also known as spark-making stones. You know, the kind of discovery that makes you go, aha. They figured out that flint could throw fiery sparks when struck against iron-rich minerals like pyrite. Imagine the moment. Sparks flying and the first humans realizing they could create fire on demand, transforming the prehistoric drama of "Where's the closest cave" into a wild, fiery adventure. This legendary spark making was a game changer, liberating folks from waiting for Mother Nature to serve up flames. Armed with their newly discovered flint tools, ancient humans became fire-generating wizards. The rhythmic strike of stone against stone became not just a survival technique, but a full-on ritual, almost like the world's first fire dancing session. Every successful spark was a mini celebration, a joyful high five to human ingenuity taking center stage against the universe's randomness. The magic of fire. It didn't just warm cold nights, it revolutionized how humans dined. Cooking became the highlight of the day, as heat broke down those tough proteins and starchy bits, transforming meals into gourmet leftovers for the brain to feast upon. Who knew that while making soup, prehistoric chefs were also simmering genius? More energy for brain development meant better ideas, more art, and even deeper strategies for dealing with pesky predators. Talk about a multitasking culinary endeavor. With fire's friendly embrace, humanity ventured into colder climates, outsmarting winter chills while showing the woolly mammoths how to really throw down an invitation to roast marshmallows. Suddenly, survival wasn't limited to the sunny savannah. It became an adventure where every new place was just another excuse for seasonal campfire songs. And let's be honest, what's an adventure without a good sing-along? Fire also turned into a health guru, sterilizing water and food, knocking out disease. Like a seasoned bouncer at a rock concert. Gathering around the fire created more than warmth, it sparked social transformation. Cooperation took the stage, replacing competition as everyone shared their stories, dreams, and, naturally, roasted caveman-style critters. The campfire community was born. This transition to a fire-loving society marked humanity's grand leap from mere instinct to the sophisticated dance we now call civilization. Turns out, the nudges from fire were changing anatomy and culture long before reality TV made being socially awkward an art form. Interestingly, some early cultures firmly believed that each flame held a spirit, a tiny flickering personality. I can't help but chuckle at the idea of a spirit named Blaze, forever in charge of keeping their marshmallows perfectly toasty. The story of human evolution simply can't leave fire out of the equation. This fierce companion led us from savannas to cozy corners, turning survival struggles into a warm, spirited gathering. It's clear, fire was, and still is, humanity's fiery hug from the universe, proving that with enough creativity, a little spark can light up the entire world. In the very heart of ancient myths, fire was not just a mere flicker or a glowing ember. It was seen as a sentient entity, living and breathing with an attitude all its own. Imagine flames dancing around like excited children at a birthday party, believed to weave a direct line of consciousness between the earthy and the divine. With offerings of tasty morsels, oil, or fragrant incense, people treated these ritual fires like precious friends. Because really, who wouldn't want to keep a divine spirit on their good side? These flame-tinged gatherings were serious business. Each flicker of light was believed to carry prayers soaring upwards in a cloud of smoke, transporting hopes and wishes to a higher realm. In sacred temples and cozy hearths, fire was both a trusty tool of everyday life and a mesmerizing presence embodying purity and renewal. Watching it consume the old to create the new was like witnessing magic. No wonder people were in constant awe of the fire's transformative powers. Now, let's talk about the ultimate party trick, ritual fires. They lit up the skies at solstices, harvest celebrations, and equinoxes like a dazzling disco ball. People did not just celebrate the cycle of seasons. They connected profoundly with the cosmic rhythms of the universe. Villagers, priests, and dreamers gathered round these mesmerizing flames, watching as sparks flew upward like whispers of gratitude and hope sent straight to the heavens. It was a fiery reunion of Earth's festivities and celestial wonders. Contemplating the blazing beauty, you could almost sense time swirling around like a brilliant flame. The cycles of life, from birth to transformation to eventual fading, mirrored the life of burning logs. Humanity became entranced by this rhythm, the ignition that launched new beginnings. The brilliant middle where dreams danced, and the slow, graceful fade into embers that reminded everyone of life's inevitable conclusion, cosmic poetry. Anyone. The majesty of ritual fire celebrated the world as a living, breathing entity, where everything felt cyclical and delightfully divine. Picture gathering around a blaze with faces illuminated, stories swirling in the warm glow, while everyone shared a knowing glance that felt as ancient as time itself. It wasn't just about warmth, it was about the very pulse of existence, reverberating with the vibrancy of creation and rebirth. Amidst all this flame-taming glory, humans also stumbled upon the genius of charcoal, the first engineered fuel. Long before the coal mines or oil rigs became the party hotspots, our ancestors discovered the art of creating a lighter, purer fuel by burning wood without air. It's like they unlocked the door to the fiery club that would fuel civilizations for ages. Who knew they were such innovative little firebugs? So, in every flicker of flame today, we can still feel that ancient pulse, absorbing the rhythm of the cosmos. Whether it's lighting a simple candle or revving up a campfire for s'mores, every spark echoes the timeless connection between humanity and the divine, a reminder that our essential energy, warmth, and soul are forever intertwined in this captivating dance of life. With every light up, we not only honor our fiery past, but we also celebrate the continuity of human spirit across time and culture. Picture it, ancient humans huddled around a fire. When someone has the brilliant idea to cover wood with clay or soil, lo and behold, they create charcoal. This black, porous gem wasn't just a pretty face, it burned hotter, cleaner, and lasted longer than any broken branch from the bush. Who knew that smoldering wood could be the flashpoint of revolutions? Charcoal didn't just ignite fires, it catapulted entire economies into action, powering forges and kilns and melting metals like a champ. Not only was charcoal transformative, but it also winked at the art of chemistry. Archaeologists have unearthed charcoal pits from tens of thousands of years ago, resembling nature's first how-to guide on manipulating matter. Suddenly, raw wood was out, and this compact wonder was easy to transport and storable indefinitely. This was not just a minor detail, it marked the dawn of human ingenuity, where a flickering flame became a crafted tool, bridging the gap between the wild and the engineered. But hold on, the fire was about to get even more revolutionary. Before mastering the heat, people were like wandering nomads, flitting from sunny spot to sunny spot. Enter charcoal. With its toasty warmth, it opened the door to colder climates. Now, families could snuggle up in cozy homes during frigid winter nights, preserving food and even growing their vegetables. Hearths popped up like mushrooms after rain, as stable settlements flourished, weaving communities into the formerly barren lands. That's right, ancient civilizations were built around the flicker of firelight. As household dynamics changed, so too did the role of fire. It wasn't just a warmth provider, it became the superhero of comfort and safety. Who would dare wander into the dark woods when they could have a trusty hearth? Flames turned wild territories into welcoming havens, providing light, defense from lurking predators, and even the glow of social gatherings as darkness fell. Those glowing embers symbolized humanity's leap into civilization. Now, let's talk about pottery, a serendipitous stroke of genius. Imagine someone accidentally leaving clay too close to a fire. Next thing you know, the clay hardens, transforms, and becomes a new wonder material. Talk about being in the right place at the right time. The crackling hearth turned this once fragile earth into sturdy bowls and vessels. Suddenly, food and water didn't just sit on the ground, waiting to be spilled. They had stylish new homes, thanks to the accidental artistic endeavor of our ancestors. With pottery in the mix, life took a joyous turn. Storage became a breeze, and cooking, a culinary revolution. Those early communities, once focused on wandering for sustenance, began to settle and thrive, growing crops and raising livestock. The clay and fire concoction helped humans stand firm in one location, allowing time for families to craft rich lives rather than mere survival. Community gatherings could finally revolve around feasts and celebrations, rather than just fleeting foraging trips. All of these firsts were all thanks to the indomitable spirit of fire and creativity. Humans had a knack for transforming challenges into opportunities. What was once a simple flame now had morphed into a powerful ally. The humble act of smoldering would pave the way for a world rich with innovation. So next time you see a glowing ember, remember our ancient ancestors and give a little nod to the spark that set civilization ablaze. As time marched on, our ancestors got crafty with fire. They evolved from flickering open flames to advanced kilns that could crank up the heat like a pizza oven on steroids. This step up didn't just improve functionality, it led to a fire-fueled renaissance of creativity. What was once a basic pot became a canvas for painted and carved designs, transforming everyday objects into art that showcased human expression. Talk about a glow up. Every shard of pottery dug up today tells the tale of that monumental discovery. Fire doesn't just destroy, it can create too. Pottery isn't just a utilitarian invention. It's one of humanity's earliest tech revolutions, born from a happy accident and a keen sense of observation. Picture this: earth, water, and flame holding hands in an epic dance, leading to those beautifully shaped vessels that echo back to our ancestors' trials and triumphs. But wait, there's more. The story of metalwork began with the flickering embers of ancient campfires. Can you imagine folks noticing shiny beads glinting among the ashes? That first accidental encounter birthed metal. Molten droplets of copper or lead somehow sprouted during fiery gatherings. And suddenly those ancient humans were drawn to shiny objects like raccoons to glitter. Curiosity ignited the flame of metallurgy, expanding what the world could bring forth from the earth. With the magic of charcoal and air bellows, raw ore was transformed into tools and shiny ornaments, helping humanity ditch the old Stone Age methods. Metal was the upgrade everyone needed, not just for its strength and flexibility, but also for its transformative power in society. Imagine that little Mississippi River of shiny goodness changing the course of civilization. Talk about a toddler revolution. And oh, who could forget about glass? Legend has it that ancient merchants stumbled upon it while cooking with mineral soda on a sandy beach. With an almost magical twist of fate, sand melted into a clear, shimmering wonder that puzzled and enchanted them. Was it mere coincidence, or was it a beachside miracle? Wherever heat met silica, a new material was born, empowering humankind to create everything from beautiful glass vessels to protective windows, each spellbinding piece a testament to fire's new creative prowess. As if that weren't enough, lightning strikes and volcanic flows also forged natural glass, kickstarting a trend of imitation by zealous artisans. Learning to replicate the process turned glassmakers into the alchemists of their time, wielding fire like wizards to transform mundane sand into glistening clarity. Fast forward to today, every lens, window, and fine vessel we hold can trace its roots back to the audacious moment someone dared to gaze into melting sand, spotting a miracle. And speaking of light, the first torches were born likely from resin-soaked pine sticks. Imagine cavemen swirling around their fiery sticks, lighting up the night as if in a primal rave. Those humble beginnings set humanity's path ablaze, each flicker and crackle paving the way for all the wonders to come. Now, every nighttime adventure is a direct descendant of that first resin-imbued torch that brightened the darkness, fueling our imaginations through time. Before the invention of candles and oil lamps, our ancestors found brilliance in the humble torch. Imagine sticks smeared with resin-rich sap from pine or birch, igniting to produce a bright, unwavering light. These portable lights became heroes of the past, guiding the way through dark caves, helping hunters sneak up on dinner, and lighting the way through forests, making adventure a little less risky. Resin not only fueled the fire but also acted like a sticky guardian, keeping the ember safe from pesky winds and unexpected raindrops. The life of a torch extended far beyond mere utility. It became a symbol of ceremonies and the keepers of knowledge. Just think about it. The steady flame stood for hope in the dark, illuminating paths in both a physical and spiritual sense. Those flickering lights turned into portable suns, shedding light in the vast darkness of the prehistoric world, allowing humans to explore deeper crevices and create stunning cave art while they embraced the shadows around them. Then came early lamps, which switched the game up a notch. Forget about fancy wax candles. These were bowls made of stone, shallow, and filled with good old melted animal fat. A simple strip of plant fiber or moss acted as a humble wick, drawing the liquid up to create a dim yet loyal flame. This arrangement lit up early homes, caves, and even sacred spaces, filling everything with a rustic charm, albeit one accompanied by the distinctive smoky scent clinging to the walls, reminiscent of ancient gatherings. Archaeological digs show off intricately carved lamps that resemble animals or boast of spiritual symbols. They weren't just light sources, they were pieces of art, adding flair to the ancient decor, while offering companionship on dark nights. Each of these lamps held a piece of sunlight, tamed for indoor enjoyment, whispering secrets of warmth and light while the world outside remained shrouded in mystery. Fast forward to fire temples, where flames burned continuously, blazing defiantly against time. In ancient Persia and India, sacred fires received royal treatment, cared for diligently by priests who fed them with offerings of wood and oil like they were pampered pets. These flames represented eternal truths, purity, and divine order, symbolizing the cosmic balance human beings craved amidst the chaos of life. Inside these sacred spaces, the priests tended to the flames, ensuring they glowed brightly and never flickered out. Just picture the rituals performed, enveloped in the warmth and glow of the flames, names chanted, hands lifted, prayers whispered. It was a mesmerizing experience, the flickering light casting exquisite shadows, making the leaders feel closely connected to something greater than themselves. Torch, lamp, or temple flame, each form represented humanity's singular quest for light amidst the endless night. They were truly magical, these fiery companions, guiding us through our history and illuminating the path forward. So next time you flip a switch or light a candle for ambience, remember that our ancestors had their own creative ways of sparking their nights and adding a little light-hearted joy in the shadowy unknown. The eternal flames that flicker across the globe symbolize the unbreakable bond between the material and spiritual realms. For worshippers throughout history, letting the fire extinguish would mean severing a cosmic connection, an absolute no-no. Some of these flames still dance in the wind today, either fed by natural gas vents or nurtured by generations of devotion. They remind us of humanity's long-standing admiration for light, a vibrant emblem of life while shining in the shadow of empires. But let's be honest, the glow of these flames was never just about cozy warmth or radiant brightness. No, it represented continuity. It was the beacon that outlasted both kingdoms and civilizations alike, cradling the very essence of belief within its flickering light. When mythologies around the world speak of gods snatching fire for mortals, they hint at a deeper truth buried within the tales. The fire wasn't just a hot commodity. It was a divine treasure. Take Greek legend, for example. Prometheus, the ambitious titan, famously swiped fire from the gods, enduring eternal punishment as a result. He acted out of compassion. But wow, did he deliver a powerful spark to humanity's intellect. Meanwhile, in Polynesian lore, the crafty Maui made off with fire from the underworld who knew he had such daring. And let's not forget Native American stories where clever animals teamed up to secure this fiery boon for the first people. Each of these stories underscores the risk and reverence tied to fire, painting it as both a blessing and a curse. Fire symbolized an ancient bond between knowledge and rebellion, igniting the spark that distinguished humans from everything else out there. This mythical heist of fire touched on a pivotal moment in human history, the juncture when intelligence and spirit converged, paving the way for civilization as we know it. No matter the culture, these tales sing a familiar tune that fire brings with it both empowerment and responsibility, forever woven into the fabric of humanity's heart. Now, if you think of fire in the wild, it's a far different story, a fierce, untamed dancer in the cosmic ballet of nature. Long before humans graced this planet, massive lightning strikes would set off wildfires, initiating cycles of destruction and rebirth. These natural infernos shaped ecosystems in remarkable ways, clearing out old underbrush, releasing essential nutrients, and making room for vibrant new life to flourish. Who knew Mother Nature was such a meticulous gardener? And plants? Well, they're like survivalists at heart. Many have evolved with fire's rhythm, developing seeds that wait patiently for the right cues, heat or smoke, to spring into action and sprout. Talk about dedication. Fire hasn't just influenced the land, it has left its mark on the atmosphere as well, enriching the air with gases that make up the breath of our planet. In essence, fire is as much a part of Earth's narrative as any superhero saga. It's a wild ride of chaos and beauty, always entwined with life's ebbs and flows. Wildfires are often seen as pure destruction, but let's give the fire a break. In the grand scheme of nature, these blazes play a crucial role in maintaining the delicate harmony of ecosystems. Picture this: forests and grasslands are living entities that require little chaos now and then to thrive. Fire acts as that necessary disturbance, rejuvenating everything it touches. Each fiery episode isn't just a disaster, it's a plot twist in nature's own novel, a tale of creation intertwined with destruction. You see, some plants have figured out a clever little trick to thrive alongside these wildfires. They produce adorable cones or seed pods that stubbornly cling shut until exposed to sweltering heat. When a wildfire rolls through, it's like the plants throw a party. The heat melts the resin or cracks open the shells, spilling forth seeds into the nutrient-rich ash left behind. Talk about a perfect timing. New growth springs up when there's little competition, and the soil is virtually fertilized. Take, for instance, the majestic giant sequoia or the lodgepole pine. These trees are fire aficionados. Their reproduction relies heavily on the fiery dance. Without that timely heat and ash buffet, these species would struggle to keep their lineage alive. It's fascinating to think of fire as a nurturing partner rather than an evil predator, isn't it? The forest may burn, but the future generation waits patiently beneath the surface, ready to greet the world with open branches. Now, let's visit those enigmatic pine cones high in the mountain forests and across the dry plains. Imagine these cones hanging around for years, looking all sealed up and unfriendly. They're like introverts at a party, hanging tight until the right moment strikes. When the flames roll through, that resin seal softens, and bam, the cones pop open, releasing the seeds to dance through the freshly cleared ground. This nutrient-rich bed is a nursery for new life. How adorable. This dance between trees and flames has been going on for ages, a steady partnership in the forest. Without these regular burn parties, the forest would risk becoming a wild, tangled mess, stifling the growth of its own future. Every pine cone that opens post-fire offers a cheerful message about life adapting through adversity, a true symbol of resilience. But wait, let's not forget the lively grasslands. These vibrant ecosystems also rely on the cleansing power of fire. From the savannas of Africa to the prairies in North America, natural fires are the ultimate cleanup crew. They sweep through, removing dead vegetation and recycling nutrients, ensuring that trees don't crash the open plains party. Without these fiery interventions, grasslands would lose their sparkle, becoming overgrown and less vibrant. In this comedic dance of flames, seeds, and foliage, nature showcases an extraordinary truth that destruction can lead to profound opportunity. So, the next time you hear about a wildfire, remember that it's not just about the smoke and destruction, it's a wild and necessary twist in the never-ending story of life. After a good burn, the world quickly bursts back to life. Grasses aren't ones to hold a grudge. Rather, they spring back with vigor, rejuvenated by the mix of sunlight and the nourishing ash left behind. And guess what? Animals can't resist the tender, green offerings that pop up from the scorched earth. It's like an all-you-can-eat buffet, and before you know it, the wildlife returns, munching blissfully on the fresh shoots and celebrating nature's way of hitting refresh. Indigenous cultures were way ahead of the game when it came to understanding this cycle of fire and renewal. They practiced controlled burns to keep the balance in check, ensuring that these ecosystems thrived. Without a little charred action, grasslands would slowly morph into thick forests and lose their rich diversity. It turns out that fire isn't a villain in nature's story, it's more like a quirky gardener, always pruning and nurturing the land in a dance as old as the earth itself. The aftermath of a burn is astonishing, a bustling, green revival that signals nature's quiet way of showing it's ready for a fresh start. And speaking of fire, did you know thousands of natural fires get sparked by lightning every day? Lightning is having a party somewhere on the globe at any moment, igniting little wildfires in forests, deserts, and grasslands alike. Most of these fires fizzle out before they get going, but some unleash a full-on inferno that can reshape ecosystems quicker than a chameleon changes colors. Every lightning strike is a reminder of the incredible forces at play. That flash in the sky isn't just a pretty light show. It's a powerhouse of energy, heating the air to insane temperatures in a split second. When this searing heat meets dry plants, hello flame, lightning-driven fires are among the planet's oldest processes, helping to maintain the vital balance of life long before the first Homo sapiens even thought about building a fire for cooking marshmallows. Now, modern technology is on the case, with satellites flying high to monitor these fiery events daily. They track lightning strikes, revealing intricate patterns that show how weather, climate, and vegetation all get along or sometimes don't. What starts as a mere flicker in the clouds turns into Earth's very own recycling program, showcasing how even destruction does have a purpose in nature's master plan. Once the flames have danced their last jig, a rich gift of nutrients emerges from the ashes. When vegetation gets crispy, the organic matter holding onto essential nutrients breaks down, flinging minerals like potassium, calcium, and phosphorus into the soil. These goodies mix with rainwater, making their way down to the roots of new plants, resulting in a spectacular surge of fertility in the seasons that follow a fire. Even the humble ash plays its part, acting like a mild fertilizer that balances soil acidity and enriches the ground for the next wave of growth. It's like nature's version of a kitchen compost, ensuring that nothing in the forest is ever truly lost. Fire is a transformational powerhouse, taking locked-up energy and matter and turning it into something new and nourishing for life. So here's to the fiery cycle of destruction and renewal, an eternal dance of balance that keeps our ecosystems thriving. The cycle of destruction and renewal illustrates a cosmic dance where fire is the sizzling lead. It's fascinating how the charred remnants of a fiery spectacle hold the key to rebirth. Each new green sprout that dares to peek through the ashy ground carries the fiery tale of its origins. It's like nature's way of reminding us that even devastation isn't the end, it's just a dramatic backdrop for a budding renaissance. The grey powder left in a fire's wake is more than mere ashes, it's like nature's special spice mix. This fine dust is brimming with mineral magic, making the soil party ready for new plant life. The miracle of ash is that it can neutralize pesky acidity, transforming hostile soils into welcoming homes for flora to set up shop. Once rain falls into this mineral-coated terrain, it becomes an elixir that increases microbial activity, stirring up a feast of nutrients for the aspiring new plants. Farmers, those modern-day alchemists, have long acknowledged ash's power to enrich fields, mirroring nature's tutorials. With a sprinkle of wood ash, they tap into the ancient wisdom of the earth. Forests echo this activity, where seedlings break ground in previously inhospitable spots. Even volcanic regions, initially blanketed by ash, showcase nature's resilience. It's heartening to witness nature flipping the script, turning barren wastelands into vibrant ecosystems bursting with life. But let's not forget the birds talk about resourceful. Imagine raptors like black kites strutting about with smoldering sticks, turning them into fiery arrows aimed at boosting their dinner prospects. These clever creatures help usher insects, lizards, and tiny mammals from the shadows straight into the jaws of their waiting talons. That's right, birds playing with fire is not just a spectacle, it's a well-planned scheme of avian brilliance. This practice, aptly dubbed by indigenous folks as the behavior of firehawks, showcases animals using fire as a hunting tool. Now housed at for evolution showing off, it's an exciting revelation for scientists witnessing this interaction, as it raises eyebrows and admiration alike. Instances of such manipulative behavior blur lines between simple instinct and honed intelligence, reinforcing the narrative that nature is full of nifty surprises. So, don't be quick to judge fire as merely a harbinger of doom. In this saga of Earth's reiteration, fire is the main magician, crafting not only landscapes but also animal behavior. The interplay between flames and flora creates an extraordinary ambience where the raw force of nature gracefully teaches the dance of survival and adaptability. It's a continuous saga of life unfolding, proof that with every season of destruction, there's always a thrilling sequel titled Renewal. Picture a beetle, but not your average garden variety. This little critter has a passion for heat. Certain species of fire beetles have developed a talent for spotting infrared radiation emitted by wildfires from miles away. Instead of fleeing these blazes, they zoom right in, drawn to the promise of freshly burnt wood. This is like a beetle's version of an all-you-can-eat buffet, perfect for laying eggs and starting a new generation of char-loving larvae. Equipped with specialized sensory organs that rival modern technology, these beetles are incredible in their ability to detect temperature variations with mind-boggling precision. We're talking small changes of less than a single degree. It's as if they've got their own built-in thermal scopes. This sharp sense helps these beetles thrive in environments where other creatures might be hesitant to tread, allowing them to turn the ashes of destruction into a breeding ground of opportunity. The relationship between fire and these beetles is a masterclass in adaptation. They've evolved to follow fires with the same zeal that other creatures track water or sunlight. This instinct ensures their survival amid the fiery chaos of the ecosystems they call home. Who would have thought these tiny beetles would have such dramatic ties to the cycles of destruction and renewal that fire instigates? When fire sweeps through an area, the impact is not just a brief flash in the pan, it transforms landscapes at lightning speed literally. Unlike the slow, patient whispers of wind and rain that reshape the earth, fire makes its mark in moments. A single flame can clear away thick forests, opening up the ground to new life, which quickly makes its appearance, like guests crashing a party after the main event. The aftermath of a blaze is nothing short of astounding. As hillsides turn black and vegetation gets a fresh start, entire ecosystems shift gears. What was once home to one type of life can become a vibrant biome filled with different species within just a few days. The speed at which this transformation occurs is a reminder that nature is not just slow and steady, it can also change the game in an instant, leaving room for rebirth and rejuvenation. Over centuries, this fiery phenomenon has led to the creation of permanent biomes, such as savannas and shrublands. This not-so-delicate dance of destruction and creation showcases fire's undeniable power as sculptor of landscapes that shapes them into something new and extraordinary. Fire doesn't just alter the ground beneath our feet, it reshapes the very fabric of life, making room for new beginnings amid the ash and smoke. Even in the seemingly harsh desert ecosystems, fire plays a vital role. Small fires help maintain a delicate balance, preparing the ground for new growth and opportunities. Just like those dedicated little fire beetles, the existence of fire is intimately woven into the tapestry of life on Earth, reminding us all that from chaos can spring forth renewal, and sometimes, the most profound changes come in the blink of an eye. In the relentless dryness of deserts, fire isn't a common guest, but when it shows up, it struts in with a purpose. Picture this: sparse shrubs, hardy grasses, and a dash of scattered vegetation burst into flames, igniting a wondrous cycle of life. These quick blazes not only banish dead plant material but also sprinkle a little sunshine happiness on new shoots. It's nature's way of recycling nutrients and keeping the fragile ecosystem alive, even in the trickiest conditions. Now, let's talk about some truly crafty desert plants. With their thick bark and waxy coatings that could rival any superhero's armor, these green warriors are perfectly equipped to withstand the heat. And that's not all. They've got nifty seeds designed to just chill out and wait for the perfect moment to spring back to life. When fires sweep through, these plants are almost impatient for the warmth to subside so they can jump back into action and flourish anew. But plants aren't the only ones putting on a show. Desert critters have developed their own fire escape plans. While the flames dance, they're either hunkered down underground or scampering off to rocky hideouts, waiting for the desert to cool off. After all, who wants to roast? By swallowing the old growth in their fiery embrace, these flames eliminate competition, ensuring that every drop of water is maximized, allowing life to thrive in this seemingly barren land. Let's not forget the aftermath of a wildfire. Those charred, ash-laden landscapes might look like a post-apocalyptic movie set, but they're more than just a blackened graveyard. The carbon-rich residue transforms into a moisture-magnifying blanket, absorbing rainfall and combating parched soil. Beneath this layer of devastation, seeds and roots get cozy, insulated from the harshness of the sun above, patiently waiting for something nice, like rain. And here's a fun twist. Scientists have discovered that the soil beneath these charred remains actually acts like a sponge. Imagine that. It retains more water than its untouched neighbors. In this ironic dance of destruction and creation, life waits in the wings, eager for rain and sunlight to spark a fresh start. The silent, seemingly lifeless forest floor is just brimming with the potential for renewal, a testament to nature's resilience. Fear not, because fire also plays matchmaker for migrating animals. Across continents, where there's fire, there are tasty new greens. Grazers trot in the footsteps of flames, devouring the rejuvenated shoots in their wake. Birds of prey get a front row seat to the action, lurking at the edges to snag a snack from the critters scrambling to escape the inferno. It's like a buffet opened up for all, thanks to Mother Nature's fiery touch. Even massive migrations in far-off places like Africa and Australia cleverly juggle their schedules with seasonal burn patterns. Fire isn't just a destructive force, it's a rhythm of life, prompting creatures to move and adapt. Can you imagine the planning that goes into their journeys, making sure they follow the right course dictated by old flames? What a world of fiery fun and green after parties waiting to be explored when the smoke settles. As time goes by and flames flicker, they create unseen trails across the landscape, effortlessly guiding herds, flocks, and even the more cunning predators. It's like nature's very own GPS, but with more smoke and fewer annoying pop-ups. Fire acts not just as a whimsical force of destruction, but more like a dance floor, setting the rhythm of movement for entire ecosystems. When the fiery spectacle fades, life gets busy retracing paths once illuminated by wild flames, forging new relationships with the blackened earth beneath. Oh, the drama continues when smoke decides to ascend into the sky. Up it goes, taking tiny particles along for the ride. These minuscule bits of ash and carbon get cozy in the atmosphere, becoming condensation nuclei, all fancy talk for water vapor's new best friends. Clouds start to form as these particles gather around their newfound pals, thickening into storm systems that eventually unleash a deluge of delightful rain. Talk about a plot twist. The very smoke we sometimes dread can help rejuvenate the earth it once tried to scorch. But hold on, not every transformation is a happy ending. Too much smoke can rudely crash the sunlight party, blocking rays and cooling the atmosphere, which can throw a wrench in cloud formation. It's a tricky balance, one that meteorologists scramble to decode as they connect fire's fiery dance with climate changes both locally and globally. Who would have thought that smoky chaos could lead to such cloud turmoil? Nature, it seems, is full of surprises. The aftermath of fire is like a secret nightclub opening for those niche species that revel in charred surroundings. Enter the fungi, hidden beneath the ashes. These fungi are waiting, perhaps polishing their dancing shoes for the heat and unique chemical changes only a fire can provide. Soon enough, once the ground cools, they burst onto the scene, sending up dark, charismatic bodies that thrive on the remains of plants and trees, putting on quite a show in the barren landscape. Fungi do more than just party, though. They have an important ecosystem role, breaking down the carbonized material and sending nutrients back to the soil for the plants that dare to appear. And let's not forget our star player, the morel mushroom. These little wonders have a flair for forming exclusive partnerships with burned trees, becoming the life of an otherwise dull post-fire gathering. As nature unfolds its story, it becomes evident that destruction can yield delightful opportunities for new life. Charred landscapes are transformed into vibrant eco-frogger tracks for resilient species, each forming a delicate web of existence, bringing balance back to the scorched earth. Together, they illustrate the resilience of life dancing through adversity, mixing fire with rain, and showing us that, even in devastation, life has a way of not just recovering, but thriving. For foragers, the arrival of fungi after a fire is like an invitation to the party. It's the ultimate sign that life is gearing up to reclaim its territory, rewriting the soil's chemistry with a flourish. Sure, fire might do a number on the surface, but down below, these tiny champions are crafting fertile possibilities from the ashes. They're nature's little miracle workers, breathing new life into the otherwise dull aftermath of destruction. Imagine the sprawling prairies of North America, once ablaze with massive fires fueled by lightning and arid winds. These flames didn't just pop up for a quick thrill, they traveled for weeks, lighting up the wildest corners of the ecosystem. But fear not, instead of spiraling the environment into chaos, nature's flames were more like a spa day, rejuvenating the land. The perennial grasses developed some serious survival skills, with deep roots that boldly defied the heat, allowing them to bounce back in no time. And who could forget the hungry herbivores? Bison and antelope literally made their living off the fresh shoots sprouting after the flames had faded. The post-fire landscape wasn't just a renewal, it was a buffet. The smoke from these ancient infernos danced across the sky, reminding everyone that rebirth was the name of the game, not destruction. The indigenous peoples were savvy to these rhythms, wielding controlled burns like a knowledgeable chef seasoning their dish, all while balancing the intricate ecosystem. In contrast, the modern landscape has quieted down, as if it's forgotten those great feasts of flame. Yet, buried deep in the soil are memories from days when fire swept over the land, like a frenzied artist with a paintbrush in flames. Today, we might overlook this ancient wisdom, but nature's collaborative spirit persists, elegantly waiting for an opportunity to rekindle this fiery dance. Head to the tropical savanna, and you'll see how life embraces fire as a regular visitor. Grasslands flourish with a unique cocktail of grass, trees, and seasonal rains while leaning into the flames for renewal rather than devastation. When fire reaches these vibrant ecosystems, it's party time for the grasses and trees wrapped in thick bark. They bounce back with an energy that sets the stage for the grand ball of life. Featuring elephants waltzing next to lions and antelope. Without the flicker of flames, these iconic landscapes would dramatically transform, losing their vivid identities. Stay alert, scientists have determined that even nature's lightning can maintain this balance, metamorphosing the savanna into a lively tapestry of biodiversity over time. Fire not only draws boundaries but sculpts the living masterpiece, preserving wide open spaces that host a myriad of animal life. Behind every spark lies a timeless collaboration of earth, rain, and flame, an ongoing partnership keeping the land's vital breath alive. Think back to those ancient lightning strikes that may have sparked the first grasslands. Fire continues to play its role in shaping life, proving that from ashes come new beginnings, and the dance of renewal rumbles on, ready for the next spectacular performance. Millions of years ago, when the world was feeling a bit parched, lightning was busy throwing fire parties across wooded plains. With every zap, the subsequent fires whizzed through, clearing trees and shrubs like a stubborn kid with a broom, leaving behind wide open spaces for grasses to flourish. These fiery festivities laid the groundwork for vast savannas, prairies, and steppes, which now waltz across much of our planet. As the sun shone down on these newly minted grasslands, the critters living there had to step up their game. They adapted their grazing and migration patterns to match the ballet of flames crackling in the distance. Talk about dancing to the rhythm of nature. Lightning became the ultimate cosmic architect, crafting a fresh ecosystem by transforming dense forests into vibrant open grasslands, those charcoal-laden soils. They tell the tale of this earth-shattering shift. Charcoal, a party crasher of sorts, showed up when wood burned imperfectly, leaving behind a form of carbon that wasn't keen on fading away. Rather than blasting back into the atmosphere, this resilient substance snuggled into the soil, remaining there for hundreds or even thousands of years. Enter biochar, the eco-friendly superstar. Scientists discovered its magic. It boosts soil fertility while keeping carbon in check, making it a win-win for both crops and climate. The floors of ancient forests across the globe hold this treasure in quiet reverence, silent archives of past fires that still rock the planet's chemistry. In recent years, researchers have kicked it up a notch, using controlled burns to create biochar for sustainable agriculture. Who knew that Mother Nature's happy accidents could spark such genius in human innovation? The fire that once burned indiscriminately is now a tool that helps us strike that perfect balance. Even more fascinating is the reality of fire's duality, acting as both a bustling creator and a merciless destroyer. Just take a moment to appreciate the paradox of those flames. They gobble up trees and brush, but also free up precious nutrients for new growth. They turn chaos into clarity and pave the way for life after a fiery detour. Nature truly knows how to play the game of survival. In this grand tapestry of existence, every layer of ancient charcoal under our feet is a reminder. Even what seems like the remnants of destruction can have life-changing purposes. Each charred fragment whispers stories of the past while cradling seeds for the future. Fire, with its unpredictable behavior, is a teacher and a trickster, constantly reminding us to embrace both sides of nature's coin. In the wilds of nature, the dance between destruction and rebirth is a fascinating spectacle. Picture this: forests ablaze, charred remains left in the wake, yet in that fiery aftermath lies hope. It's here that life begins anew. Seeds, warmed by the heat, start yearning to sprout. Fungi, the not-so-glamorous recyclers, feast on the ash. Even critters swing by to resume their roles in this refreshing play of life after a fiery intermission. Without a little fire flare, ecosystems turn into ho-hum. Overgrown jungles, think of it as nature's version of a never-ending, boring soap opera. But once a fire flares to life, it brings with it that much-needed makeover. Flora and fauna spring into action, reclaiming their homes in this vibrant comeback story. It's all about finding that balance, that perfect blend of life's end wrapping around to its refreshing new beginnings. Researchers digging into fire's secret life have unveiled its magical frequencies. Yes, the timing and intensity of a burning blaze are no fluke, but instead, carefully tuned acts of evolution. This once feared element, historically notorious in humanity's past, has transformed into an ancient artist, painting vibrant shades across the canvas of our planet's renewal with every new spark. A masterpiece emerges showing us just how creatively fire can redefine life itself. At the core of fire's hearty existence lies the famous fire triangle. Think of it as fire's VIP pass. You'll need three elements: heat, fuel, and oxygen. Each flame, whether a cozy candle or an inferno, owes its brilliance to this harmonious trio. When heat cranks up, the reaction kicks off. Fuel is the bouncer keeping things alive, and oxygen is the breath of life. Eliminate any one of them, and poof, the party's over. This delicate balancing act explains why damp wood prefers to smolder rather than combust, and how flames fade beneath blankets or foam. Picture this as nature's way of maintaining order. In controlled environments, like engines or furnaces, this triangle becomes an artist's palette, allowing us to craft warmth and energy with precision. Enjoy this dance. It's a thrilling reminder of energy's craving for harmony. Imagine a world where fire defies the rules of balancing act. Chaos reigns if there's an overdose of any one element. Too little. Well, that's a surefire recipe for failure. Humanity's initial scientific insights into the combustive world sprung from observing this sweet symphony of elements. Each spark, each flicker dances to the rhythm laid down by Mother Nature, from the tiniest ember to the colossal stars dotting our sky. Fire and art form balance through the genius of chemistry. Whether it's a simple campfire or the blazing cosmos burning bright, this dramatic process will stop in its tracks without the cooperation of heat, fuel, or oxygen. Lower the heat beneath ignition temperature. The spark dies. Deplete the fuel. Well, that fire just quit the scene. Cut off the oxygen. Cue the chemical chain collapse. It's all about harmony, keeping that fiery passion alive. Firefighting isn't just about rushing in with hoses and turning everything soggy. It's a delicate dance of chemistry. At the heart of it all is a simple triangle: heat, oxygen, and fuel. Take away one of those bad boys and poof, the flames can't keep partying. It's a delicate balance of elements. And who knew fire could be such a diva, needing the perfect conditions to flourish? When those conditions go rogue, the fire's bravado diminishes, highlighting just how fragile it truly is. You see, extinguishing flames isn't about obliterating the fire itself. Nope, it's about tweaking the environment that keeps the flames flickering along. It's akin to understanding that even the mightiest forces can deflate when their support system crumbles. Heat, food, and oxygen are like a bad relationship. One of them goes downhill and the whole operation can tip over into disaster. Just imagine that blazing inferno transforming into a smoldering memory, the ultimate diva drama. And speaking of dramatic transformations, let's talk about iron rusting, a process that likes to play the long game. It's like fire's slow cousin, taking its sweet time to do its thing. Instead of glowing, we've got iron doing its thing with oxygen and water, leisurely combining and releasing energy without a single flame in sight. Over the years, metal metamorphoses into a reddish oxide, showcasing a process similar to combustion but stretched over ages, like a tortoise compared to a hare in a race. Rusting teaches us that fire and its quieter counterpart, corrosion, are just two performers in the same cosmic play. They're interconnected, only divided by pace, with both desperately seeking equilibrium. The constant exchange of electrons makes the universe do a little shimmy, releasing energy and shifting matter, all while aiming for stability. It's the chemistry version of a dance-off, but with less glitter. Then there's the world of phosphorescent reactions, where things get fancy without the heat. Here, energy bursts forth not as warmth, but as stunning light. Think of it as celestial fireworks without the sizzling sound effects. This ethereal glow, found in everything from certain minerals to those enchanting fireflies, twists concepts of fire even further as it glimmers without burning. It's like a gentle whisper, delicate yet captivating, skipping the heat while making us reach for our sunglasses. And down in the ocean's depths, Some creatures have mastered this cold fire trick to perfection. They're the deep-sea stealth artists, using gentle glows of blue and green to communicate and hunt. Just picture it. Entire aquatic conversations unfolding in the darkness, where phosphorescence paints the black canvas of the ocean like a gallery of glittering stars. Who knew the ocean's underbelly could be so lively and illuminating while remaining perfectly chill? This enchanting interplay of fire, rust, and luminescence reminds us that the universe is filled with surprising connections, from roaring flames to the slow decay of metal and the sparkly flash of phosphorescent wonders. It's all part of a grand chemical tapestry. Each element does its bit in this cosmic scheme, showing us that existence is just one elaborate dance of energy, matter, and the quest for harmony. Now, isn't that a story worth celebrating? In the wild world of chemistry, scientists are hard at work deciphering the magic behind light production. They've discovered that combustion isn't the only way for matter to shine. Enter phosphorescence, a serene alternative to the fiery spectacle. Picture this, glimmering light emerging from transformation, yet entirely innocent of destruction. It's nature's gentle fire, glowing softly, casting a calm glow without wreaking havoc on its surroundings. Who knew science could be so poetic? Now, if you thought combustion was explosive in oxygen, buckle up. When pure fluorine enters the game, things get wild, even a bit scary. Known as the most reactive element, fluorine turns the combustion dial up to 11. It has a magical ability to spark flames from the most stubborn of materials. Think glass or sand. Just imagine the reaction's blinding flashes accompanied by clouds of corrosive gas, making every lab look like a mad scientist convention. Scientists tiptoe around this stuff, handling it with the kind of caution usually reserved for ninja training. Intriguingly, fluorine's eager beaver attitude can strip atoms apart faster than you can say chemistry class, which adds an extra layer of thrills to its unpredictable personality. Although fluorine could potentially outshine oxygen in theoretical propulsion systems, it's not exactly suitable for grand adventures. Its volatility keeps it on the sidelines for most applications, making it the ultimate dance partner for combustion chemistry's extreme side. Forget gentle flames, we're talking pure reaction energy, like a wild roller coaster of matter combining at brain-scrambling speeds. Switching gears, let's shine a spotlight on hydrogen, the darling of the fuel world, which burns with a nearly invisible flame. This super clean hero of combustion reacts with oxygen to create water vapor, casting aside the pesky carbon particles that love to leave their mark. What results is a flame that's so faint you'd need special glasses to even notice. Hydrogen's ghostly blue flame is like the shy kid at a party, powerful yet understated, whispering of great potential, just waiting for the spotlight. What's even more fascinating, this elusive flame can pose unique safety challenges since you can't easily detect it without specialized sensors. So, while hydrogen might lack the showy presence of other flames, it's considered the fuel of the future. With its efficiency and nearly non-existent pollution footprint, it's a game-changer in the quest for sustainable energy. Hydrogen is like that quiet genius in the lab, swirling around with ambition to clean up our energy act. But as if that's not enough to get your heart racing, liquid oxygen enters our story, waiting to spice up the mix. The moment it meets organic materials, boom, chaos ensues. The spectacularly explosive reactions leave everyone in giddy disbelief, as if the lab is the site of the most dramatic fireworks show you've ever seen. Scientists watch in awe and a bit of nervousness, noting that this means serious business. Liquid oxygen and organic materials are like a romantic comedy, filled with sparks, excitement, and the occasional catastrophic misunderstanding. In this dance of atoms and elements, we appreciate the brilliance of chemical reactions that light up our lives in unexpected ways. From gentle phosphorescent glows to explosive encounters with reactive elements, chemistry never ceases to surprise. Whether we're harnessing potent fuels or marveling at the quiet brilliance of invisible flames, science has proven that chemistry can be both enchanting and exhilarating, an unpredictable party at the atomic level. Glowing star. When paper, oil, or fabric makes contact with liquid oxygen, they don't just get a little damp, they practically dive into a chemical bath. These materials become saturated with oxygen, one of nature's most clingy and explosive elements. Disturbing them is like shaking a soda can before opening it. Just a little spark or even some friction, and boom, you've got an instant fireworks show. Engineers who work with rocket fuels or cryogenic systems know they must walk a fine line of precaution, avoiding this fiery tango at all costs. In the world of spaceflight, liquid oxygen plays the role of a supercharged oxidizer, making rocket engines burn hotter than a summer sidewalk. It's a critical part of making those engines roar to life. But outside those controlled environments, it could turn your everyday materials into an explosive fiesta, looking for the slightest excuse to ignite. It's a wild dynamic, reminding us that fire isn't just a flickering flame. It's a beautiful dance of creation and potential destruction. Speaking of flames, let's chat about sodium. When sodium gets heated, it doesn't just get hot, it glows a brilliant yellow. That's because its electrons get all excited, jumping up and then plummeting back down, releasing photons that emit a distinct golden hue. This deep yellow isn't just pretty. It's like sodium's very own signature. It colors everything from streetlights to fireworks, demonstrating how chemistry can light up the night sky and ignite childhood wonder. This sodium glow isn't just for show, it's an old-school cheat code for scientists. Before fancy equipment, they used fire as a tool to identify substances by color alone. Each element has its own fiery fingerprint, dancing in the flames to reveal its identity. So when you see that fiery spark of sodium, it's a glimpse into the meticulous order lurking within the chaos of flame, a testament to the universe's intricate design. Let's not forget about fireworks, where elements turn into dazzling displays. Different metals bring their own colors to the show. Strontium salts spill deep reds, barium shines as green, copper bursts forth in blue, and sodium draws us in with its radiant yellow. It's a collaborative performance, where chemistry takes center stage and captivates every eye in the sky. Each hue tells a story, a colorful symphony orchestrated by the fundamental building blocks of matter. And within these vibrant explosions lies the potent reminder that chemistry brings both beauty and danger to our world. Fireworks paint the sky with allure, but behind that allure is a chemistry lesson waiting to ignite curiosity. Each display is a fleeting moment of brilliance, a spark of joy marrying the science that defines our reality. With every bang and boom, we see how the elements unite in a celebration of light and color, wrapped in the delicacies and dangers of their fiery nature. When you light a firework, it's like orchestrating a colorful symphony in the sky. Those bright flashes of reds, blues, and greens are produced by tiny atoms releasing photons, revealing the stunning artistry that modern chemists have developed. Craftsmen meticulously balance temperature and chemical composition, ensuring that each color maintains its brilliance when heated. A miscalculation can lead to an uninspiring hue that fades into the dreaded may of white. This dazzling display have ancient roots. Way back when, alchemists, the original science nerds, noticed how different minerals produced various colors when they cranked up the heat. Fast forward to today, and those casual observations have evolved into an intricate science. Armed with knowledge of oxidation and reduction, chemists now design fireworks that are not just explosions but choreographed showcases, demonstrating the beauty and precision found in the chemistry that fuels them. Inside every firework shell is like a master chef's secret recipe. It's a meticulously arranged mix of fuel, oxidizers, and compounds that produce those vibrant colors. One spark from the fuse triggers a carefully timed sequence, sending the shell racing up before it bursts into a spectacular shower of color. Each star in the sky glimmers with its own unique hue based on its chemical makeup, dancing in the air like a spectacular explosion of glitter at a party. Every aspect of a firework is calculated to perfection. Pyrotechnic engineers flex their mathematical muscles to predict the size and pattern of each bloom. They even tweak the casing to ensure those booming sounds are just right. It's like designing an explosive concerto where each burst is harmonized not just visually but also sonically, for mere moments of beauty. These displays are achievements born from centuries of experimentation in fire control and combustion. But wait, the story doesn't end there. Ever looked closely at a candle flame? It seems calm and serene, right? Yet, hidden beneath its gentle flicker, a realm of micro-explosions is happening every second. Thanks to high-speed photography, we can catch a glimpse of these countless carbon particles combusting and extinguishing faster than you can blink. This rhythmic chaos forms what we see as a steady flame, a living, breathing entity of heat and light. These miniature detonations create a mesmerizing dance of flickering light, an undeniable charm that enchants anyone who gazes upon it. Although the sounds of these micro-explosions are far too subtle for human ears, their combined effect is a luxurious shimmer that draws us in. Who knew that simple wax and a wick could house a world of tiny explosions, echoing the fantastic chemistry wrapped up around us in everyday life? In a way, firework displays and candle flames are intimate reminders that chemistry isn't just about lab coats and beakers. It can be poetic. Both phenomena showcase a wonderful cooperation between knowledge and artistry. They show us how the wild language of fire, shaped by human understanding and creativity, can transform the mundane into the magical, igniting our imaginations and lighting up our lives. Whether it's a grand fireworks show or the humble flicker of a candle, both represent the joy of science and art coming together in breathtaking harmony. In the cozy flicker of a candle, you might find yourself lulled into a sense of calm, but don't be fooled. Beneath that seemingly tranquil exterior lies a bustling marketplace of microscopic exchanges and chemical shimmies. It's a vibrant discourse of molecules in perfect harmony, breaking apart, reassembling, and dancing above the wick in an energetic frenzy. Every moment, they're throwing a wild party that sustains that radiant glow. Who knew a simple candle could host such a swirling universe of activity? Now, let's talk soot, the unsung hero of the combustion world. Picture it as a rebellious carbon renegade that couldn't get its act together during a flame's attempt at perfection. When flames don't have enough oxygen, they leave behind these tiny black particles. Like a magician's curtain call, they briefly shine orange before turning into a smoky shadow. This not-so-glamorous residue has a rich history, marking ancient caves and temple ceilings as the first witnesses of our fire-fueled exploits. Later on, it even morphed into artists' ink and paint. But soot isn't just a museum relic, it's a powerhouse that affects our modern lives, from climate change to air quality. Think of it as nature's way of saying, hey, there's an imbalance here. Like an overzealous show-off at a party, soot absorbs sunlight, warming up our atmosphere. Fire, deprived of sufficient oxygen, is like a performer fumbling through a routine, reminding us that even in heat and light, harmony is key. So, the next time your candle fizzles out with a puff of soot, remember, it's not just a mess, it's a tale of what went awry. Flame shapes are like the handwriting of chemical reactions. You could say every flicker and curve tells a story, a living graph of how efficiently those molecules are partying. The taller and sharper the flame, the more intense the reaction. It's as if the heat is catching a ride on a roller coaster, whisking away the gases while inviting fresh oxygen to the wild stallion ride of combustion. Scientists have even turned into flame detectives, studying the jagged patterns and shock waves with fancy gadgets to decode the action going on. Imagine a high-speed camera snapping shots of those flame-formed shapes, each flicker acting like Morse code that relays the velocity of molecules and heat transfer. Every bit of atmospheric change, like humidity or air pressure, can turn a flamboyant fire dance into a quiet flicker. The whole spectacle becomes a dynamic saga where beauty and science collide, as what your eyes see as a glorious glow becomes a scientist's data to dissect. So, next time you light that candle and relish its dance, know there's more than meets the eye. This little orb of light isn't merely illuminating your secrets, it's busy crafting its signature story in motion, weaving in and out of existence. Each fiery blossom and sudden extinguishment reveals how energies combine, proving that even in the intimacy of a candlelit room, science and art play a tantalizing game, in just the span of a breath. That brilliant light flickers before the world, an ephemeral ballet erased by the air, a reminder that beauty, indeed, dances on the edge of chaos. In the weightless wonderland of space, flames become nature's little artists, painting perfectly round orbs instead of the usual flickering fire. Without gravity to guide them, these flames morph into glowing spherical beauties, floating serenely like miniature suns. This mesmerizing sight occurs in the controlled confines of space stations where astronauts dive deep into the bizarre world of microgravity, studying combustion in its most elegant form, completely unbothered by the chaotic push and pull of hot and cool air. These puffy little fireballs light up the void, floating effortlessly and silently, reminding us of a distant star caught in a cosmic ballet. Curiously, these spherical flames are efficient little critters, burning coolly compared to their earthbound counterparts. This unique behavior offers exciting possibilities for tackling issues off Earth, like creating cleaner engines and more efficient fuel systems. It's as if the fires have forgotten the rules of physics, and what was once a basic element has turned into something straight out of a sci-fi novel. As astronauts observe these starlit flames, a whole universe of combustion secrets unfolds before their eyes. Without upward flow to complicate matters, the flames behave predictably, allowing scientists to scrutinize every detail of how gases mingle and reactions unfold with stunning precision. Many comparisons spring to mind, but perhaps it's like watching a slow-motion nature documentary, revealing the hidden artistry in elements as they dance together in slow harmony. These dazzling spherical flames hold clues that can help fire safety back on good old Earth. By understanding how fire propagates in microgravity, scientists can model its behavior in various materials and environments, making strides in spacecraft safety. It's a win-win for everyone: better engine designs, less pollution, and a brighter future for combustion scientists everywhere. The smooth and steady burn demonstrates what happens when convection is tossed out of the equation, leaving only the simple magic of molecular diffusion at work. In these experiments, we're not just talking about flashy fireballs. We learn about the fundamental language of combustion that dictates how everything from distant stars to our humble home candle lights up. It's a beautiful reminder of how interconnected everything is, as these spherical flames flicker in their own cosmic rhythm. They reflect processes that are prevalent across the universe, unveiling a profound simplicity hidden in their fiery depths. But it doesn't stop there. Under extreme pressure, even what we know as carbon dioxide, often a flame's most notorious enemy, can turn into a combustion buddy. Typically, carbon dioxide plays the role of an extinguishing agent that snuffs out flames by pushing out oxygen. Yet, when faced with high pressure and scorching heat, it flips the script, behaving like an unlikely friend to fire. Reminding everyone that in the curious world of science, surprises are always around the corner. Experiments have led to some mind-blowing revelations about carbon dioxide. Imagine this unassuming gas breaking apart to release oxygen atoms like a superhero in a gas mask. These reactions happen under extreme conditions, reminiscent of the fiery interiors of planets or during high-energy industrial raves. The old perception of carbon dioxide being a mere passive participant in our atmosphere just got thrown out the window. Who knew it could be such an energetic fellow when the heat is on? This wild discovery is paving the way for scientists to delve into the atmospheric chemistry of distant worlds. Think of planets where the pressure and temperature are sky-high literally. Studying these fiery reactions helps unlock the secrets of how intrepid elements like carbon dioxide behave when the universe puts them through the ringer. Even the comatose compounds, sitting pretty on their lazy clouds, have potential power just waiting for the right moment to shine. Flames aren't just about warmth and roasting marshmallows. Oh no, my friend, they're like tiny ion engines, pushing air particles around like a scene from a sci-fi adventure. What really happens in a flame is like magic gas molecules splitting into ions and electrons, which then respond to electric fields. When scientists apply a current, these charged particles kick it into high gear, generating thrust. It's called ionic wind, and it can move things lighter than feathers. How cool is that? This ion wizardry doesn't stop at merely wafting around feathers. Oh no, the same electric methodologies are being employed in some fanciful spacecraft propulsion systems. Just picture this: ionized gases being shot out into the vastness of space, steering spaceships like the coolest rollerblader in a cosmic rink. Here on Earth, in laboratories, scientists wield electric fields as if they were puppet masters, bending and shaping flames like shimmering threads of light. Talk about making fire dance. In these fire manifestations, flickers and sparks don't just ignite, they double as both a chemical reaction and electrical spectacle. It's as if they bridge folks from the world of heat to the realm of motion, revving up our imaginations about future propulsion methods. Those wispy flames remind us that fire can do more than warm our s'mores. It can exert genuine force and transfer energy in captivating ways. And let's not overlook the enigmatic cold flames. These intriguing burners are the introverts of the flame family, operating silently at lower temperatures and glowing a soft, ethereal blue, happily defying expectations. Cold flames burn so gently that they stay below the ignition levels we're used to. they're nearly invisible and surprisingly cool to the touch, opening our minds to the idea that combustion doesn't always mean blazing infernos. Yet, even in their cool demeanor, cold flames are nothing short of a miracle of true combustion. They illustrate that not all flames need to roar. The collision between science and nature has gifted us with these phenomenal reactions which, although subtle, symbolize the harmony between temperature, flame, and the combustion process. Whether it's in glitzy space missions or low-key laboratory demonstrations, the world of flames is simply unforgettable. In the world of engines and chemical reactors, there's a hidden dance happening in the shadows. Cold flames. These ghostly flames aren't your typical roaring bonfires, but rather gentle whispers of chemistry at work. Scientists, ever curious about the mysteries of combustion, study these quiet phenomena to fine-tune fuel efficiency and cut down on pesky pollutants. They've unlocked the secret that fire can exist without that typical burst of heat and light, proving it's not always the loudest blaze that makes the biggest impact. Now, let's talk about the wonders of vitrified rock. Picture this: sand and soil meeting a sizzling fate when exposed to intense heat as if they were on the hottest date ever. This transformation leads to a glassy material known as vitrified rock. It may sound like an art project gone wrong, but it's a natural process that occurs in the wake of lightning strikes or flowing lava, and even in some man-made explosions. Mother Nature and science combined give way to smooth, shiny surfaces that cool into solid stone, like nature's own colorful paperweight. Archaeologists aren't just digging up bones, they're stumbling upon ancient fortresses adorned with these vitrified walls. Imagine whole ramparts deliberately roasted to create a sturdy defense. Whether as a protective tactic, ritual offering, or war strategy, these strongholds show off their fusion with pride. The material resists erosion like a champ and stands the test of time, proudly telling tales of its fiery transformation for millennia. It's like history, but with a varnish of rock-solid resilience. But wait, lightning brings even more goodies. When that electrifying force slams into the ground, it creates a moment so hot it could rival the sun itself. This incredible surge melts soil and minerals, forging a glassy superhero known as fulgurite. They may look fragile, but inside, they hold the secrets of the storm. Iron-bearing minerals align as they cool, preserving a faint magnetic field that can tell tales of ancient strikes. It's as if each fulgurite is a love letter from the sky to the Earth. For scientists, studying these magnetic vestiges is akin to time travel. With the ability to read the direction and intensity of lightning strikes, they piece together a history of storms like detectives following a trail of breadcrumbs. Who knew that a bolt of lightning could be a historical storyteller, revealing meteorological mysteries locked within the glassy structure? Each fulgurite stands proudly, showcasing energy's fleeting artistry captured in time. Not only does lightning sculpt these magnificent rock tubes, but it also changes the very chemistry of the soil it touches. Under normal circumstances, certain compounds wouldn't dare to exist, but the intense energy of a lightning strike gives them a nudge, creating strange and wondrous combinations. Each unique fulgurite tells a story of transformation, an electrifying snapshot of where sky and earth collide in a spirited embrace, leaving behind a work of art that is both beautiful and scientifically rich. It's nature's way of capturing that exhilarating moment, frozen energy that sparks the imagination. When you hold something that once felt the heat of the cosmos, you're grasping the remnants of a flaming event that outshines any bonfire you've ever seen. Think of stars as gigantic cosmic barbecues, ignited by fusion rather than charcoal. Inside their blazing cores, hydrogen merges into helium, unleashing energy that could light up your entire block, a radiation party that keeps them glowing for eons. Essentially, these fiery balls are nature's way of reminding us that to shine like a star, you have to go nuclear. Every sunrise we experience, that's just the universe saying good morning, with energy gifted from those stellar fusion parties. The fire here on Earth is just a mere rearrangement of molecules, like playing with Lego blocks, but in the stars, they're reshaping entire atoms, transforming them in a cosmic dance of brilliance. So, when we warm ourselves by the flames, we're just catching a tiny glimpse of that stellar energy. A cosmic connection wrapped in heat and light. Then there's Titan, Saturn's enigmatic moon, where the atmosphere contains all sorts of flammable goodies like methane. This place is like a cosmic dreamscape where it rains liquid methane instead of water, creating rivers beneath orange skies that look like they've been plucked straight from a sci-fi movie. If you tossed in some oxygen, you'd have a fiery inferno dancing across the surface. But the absence of oxygen means it's chill and eerie chemical playground just waiting for the right spark to ignite a cosmic show. Scientists are all over Titan, trying to decode the drama of its chemistry and learn how different atmospheres behave in this bizarre universe of ours. Imagine a world where fuel plummets from the sky yet doesn't combust. It's like a celestial joke that highlights how cosmic balance works. Fire in space isn't just about heat, but a careful dance of conditions coming together at just the right moment. It's the universe's way of keeping things interesting. Take a trip to Jupiter's moon Io, where things heat up in a whole different way. Io's volcanoes are erupting with molten sulfur, spewing vibrant yellow and blue plumes into the chilly blackness of space. Unlike our earthly volcanoes that huff and puff in response to seasons, these eruptions are more like cosmic bellyaches, prompted by the tidal forces of Jupiter's massive presence. It's a fiery ballet, choreographed by gravitational pull. These distant moons remind us how wild and varied fire can be across the universe, whether it's the quiet, combustible rain of Titan or the explosive sulfur fireworks on Io. They illustrate that fire isn't a universal constant. It's a complex game of chemistry and forces. In this grand cosmic landscape, the heart of flames beats in myriad forms, guiding researchers to uncover the secrets of the heavens while sparking our own imaginations. So, who knew fire could be such a star-studded topic? As Jupiter smacks its gravitational fist onto its moon Io, the poor crust isn't merely shrugging off the weight, it's stretching, heating up, and sizzling like a strange cosmic grill. When sulfur gas decides it's time to escape, it doesn't just waltz away, it ignites in an explosion of eerie colors that scream, "Look at me, Earthlings." Spacecraft peering from afar capture these flamboyant outbursts, showcasing fountains of radiant materials soaring hundreds of kilometers into the void. In this chaotic dance of alien fire, Io is easily crowned the hottest volcano party in the solar system. Forget an ordinary lava flow. This moon's surface is the ultimate renewal zone. Each day on Io feels like a glorious reset as the volcanic activity continuously reshapes the terrain, making it the ultimate shapeshifter of celestial bodies. It's like watching fireworks on a cosmic scale, with flames that resemble art in motion, each eruption a testament to the wild energy coursing through this rugged little moon. In this theatrical play of fire, we find that flames are not Earth's exclusive domain. They thrive wherever the cosmos strikes an electric spark. Speaking of cosmic displays, the sun's corona is a fiery enigma that really cranks up the heat. Imagine a halo of light spinning around the sun and radiating energy at a mind-boggling number of degrees, millions hot. For context, while we chill with a toasty surface temperature of a mere few thousand degrees, the corona outshines your backyard barbecue in intensity. It's like that one over-the-top relative at a family gathering you can't help but watch but also feel kind of bewildered. It's the magnetic fields in this fiery embrace that do all the heavy lifting, twirling, snapping, and releasing bursts of energy hotter than your favorite sci-fi explosion. As these charged particles are flung into the boundless vastness, they create solar winds that go on a majestic journey, sculpting planetary atmospheres and painting the mesmerizing northern lights we see twinkling above our polar caps. The corona hides in plain sight, a silent conductor for life on Earth, connecting us more than we know to the shimmering dance of energy radiating out into space. Now, let's not forget about those dramatic meteor entrances. When one carelessly hurls itself into our atmosphere, heads up, the once calm air becomes an angry ball of shockwaves and heat, igniting woods into roaring infernos well before the rock ever lands a blow. Picture the panic of a meteor cooking up a firestorm, even vaporizing upon impact. The chaotic energy releases so fiercely that it can set forests ablaze, leaving the aftermath as an artistic layer of charcoal strewn across ancient sediments, proof that nature wreaks havoc in the most spectacular ways. These layers tell tales not just of fires but of times long ago when meteor impacts rewritten climatic stories and transformed ecosystems. Each mark is a testimony to an event that unfurled in a blaze of glory, making our planet's history as fiery as the sun itself. So, the next time you see a meteor shooting across the night sky, remember, it could be the beginning of an ethereal fireworks show, igniting tales of resilience in the face of cosmic chaos. Buckle up, folks, the universe is one wild ride. The Tundrusa explosion in Siberia has left its mark in a wild and fascinating way, uprooting countless trees but leaving no crater behind. Imagine fiery waves sweeping across the landscape, a spectacular display of nature's raw power. This phenomenon is a vivid reminder of how fire from the skies has shaped our planet's history, masking both awe and devastation in one fell swoop. Each flash of light in the night sky spins tales of cosmic calamity and beauty, linking the quiet dance of stars with life's precarious balance below. Now, let's dive into the wonders of nebulas. Picture immense clouds of gas and dust, sprawling across light years in the chilly cosmos like some artistic masterpiece. These nebulas are akin to colossal cold flames, shimmering softly with the faint light of ionized atoms. While they're not sizzling hot like stars, they dance in light thanks to exciting ultraviolet rays from nearby celestial bodies. When that happens, they release photons, painting the cosmic canvas with soft reds, greens, and violets, a tranquil fire that emits light but lacks heat. Imagine witnessing the birth of stars and planets nestled within these luminous clouds, sculpted gracefully by gravity and the relentless march of time. Observing a nebula feels like entering a time warp, watching creation itself unfold in glorious slow motion. It's as if the universe is breathing colorful life into the silent void of space, crafting a fire too vast for any hand to grasp, while its light has traveled for eons to reach our eyes. Let's take a leap to Titan, Saturn's mysterious moon, where things take a wild twist. Here, the atmosphere is thick and orange, with rivers flowing not with water, but with liquid methane and ethane. The thought of this world going up in flames is electric. Just imagine if oxygen ever entered the mix, one tiny spark could ignite a global inferno, turning Titan into a scene straight out of a sci-fi thriller. The potential for explosive chemistry is thrilling, and scientists use this wild possibility to illustrate just how fragile life-supporting conditions can be. In contrast, Earth enjoys a stability that we often take for granted. Our engines and furnaces burn fuel safely, transforming energy into the everyday comforts we enjoy. But on Titan, this combustible situation remains a ticking time bomb, just waiting for the right mix of elements. This curious balance makes the cosmos even more riveting. It's a reminder that stability is a delicate dance, where one ingredient too many could spell disaster. At heart, Titan holds a serene enigma, an untapped potential of a world with a fiery spirit just beneath its frozen surface. The calm plains hide dormant possibilities, whispering tales that combustion isn't just about destruction, it's about potential waiting patiently for the right moment to ignite. Such contrasts fuel our imagination, reminding us that the universe constantly balances between what we see and what lies beneath, often waiting for a mere breath of air to unleash its hidden fire. As we think of all these cosmic battles and potential explosions, we celebrate the wild beauty of re-entry. Picture spacecraft heating up as they blaze through the atmosphere, their surfaces glowing from the friction of atmospheric entry. It's a spectacular fiery spectacle that symbolizes both the adventurous human spirit and the intrinsic dangers of tampering with the realms of space and fire in the grand tapestry of our universe. These fiery moments encapsulate the marvel of exploration amidst an ever-changing cosmic stage. As a spacecraft zips back to Earth, it does so with a majestic flare, cutting through the atmosphere at jaw-dropping speeds. This high-speed entry isn't just a casual descent, it's more like a fiery family reunion with the atmosphere, where air is compressed so intensely it transforms into plasma. You could say this is the universe's way of rolling out the red carpet, but in sizzling shades of white-hot metal, the dazzling light show we see, not a flaming fuel fiasco, but a stunning display of superheated air flaunting its energy. To handle this scorching welcome, spacecraft equip themselves with fancy heat shields, the astronaut version of oven mitts. They're like layered cakes, absorbing the intense heat, one bit at a time. It's a mindful dance between human smarts and the raw power of physics, an elegant choreography of science and nature. Each descent is akin to a cosmic baptism, a leap through light that echoes the very genesis of the universe, where speed transforms into flames and the sky graciously splits open to embrace the homecoming. Now, let's talk about lightning, shall we? Those spectacular bolts aren't just nature's version of a light switch gone rogue. They're mini power plants bursting with plasma. Imagine the same state of matter that ignites the sun, crackling in our very own atmosphere. When a lightning bolt zips across the sky, it's like a party of electrons leaping between atoms, generating more heat than the sun's surface itself. If only we could harness that energy. We'd have cities powered up faster than you can say thunderstorm. Lightning also has a flair for artistry. Those branching patterns are like little electric veins mirroring the colossal magnetic loops of solar flares. It's almost poetic, really. Both phenomena emerge from electric fields that reach their breaking point, erupting into dazzling displays of energy. Watching lightning up close is like peering into the heart of the same forces that rage among distant stars, reminding us that the fiery magic of the universe isn't merely a distant dream, it's right above our heads, pulsing like a cosmic heartbeat. Each crackle and flash sings a reminder that every flicker on our planet shares a genetic link to the stars that birthed the very elements we cherish. The carbon, hydrogen, and oxygen fueling life and fire on Earth once swam in the guts of ancient celestial bodies. When these stellar giants had their dramatic exits, they scattered across the universe, planting the seeds for our planet. So every time we strike a match or light a flame, we're not just sparking a light, we're rekindling the ancient fire that began in the cosmos. As sparks fly and flames dance, we find ourselves engaged in an eternal communion with the universe. Every flickering flame manifests the age-old struggle of converting matter to energy, a divine act that first ignited in the hearts of stars. So, here we are on Earth, surrounded by the remnants of stellar nursery beds, participating in a grand cycle that echoes through time and space. The warmth we feel is not just heat, it's the whispered story of creation itself, celebrating the cosmic dance that links us all to the stars. A simple candle holds a cosmic secret, lighting the way back to suns that have long since fizzled out. With each flicker, whispers of ancient explosions wrap around us like a warm blanket. It's more than mere wax and wick, it's a delightful connection to the universe's wild history. The flickering flame is a tiny reminder of the grand story of creation, enfolding us in its warm glow as it sparks our imagination. As the glow of the last flame begins to dim, your mind starts to drift like a leaf on a lazy river. You've just traversed the enchanting chemistry of fire, experiencing bursts that speak in starlight and glowing embers that resonate with the echoes of existence. Each little flicker tells us that nothing really dies, it just morphs, taking on new forms, much like a shape-shifting character in a fantastical novel. Fire is the ultimate teacher, revealing how everything is in a constant state of transformation. The energy swirling around each candle is a reflection of the forces that power our very own suns. It's mesmerizing. As you sit there, enraptured by the dance of the flame, you begin to grasp how the universe constantly reinvents itself. It's like watching a cosmic show where each spark reminds us of the changes swirling beneath the surface. Who knew staring at fire could lead to such profound realizations about ourselves and the world around us? With the warmth enveloping you, the heaviness of your body invites you to sink deeper into your seat. Your breath becomes slow, matched only by the soft pulse of the glowing ember. The room softly fades into shadows, leaving you alone with the echoes of the flickering flame that seem to resonate between worlds, almost calling you to join in its whispered dance. Embrace this calming sense of calm, it's a soothing reminder from the fire. Picture it, somewhere far beyond your sleepy eyes. The stars continue to blaze, their age-old glow twinkling through the velvet darkness. They greet you in this quiet moment, an ancient warmth that wraps around you like a favorite, worn-out sweater. It's as if every spark is nudging you gently, saying, "We're still here, waiting for your return." It's a heartwarming connection, a cosmic phone call to keep you company. If somehow you're still awake with that stubborn desire to stay in the loop, dive into the next adventure, or switch on another video. But let's be real, if sleep's sweet embrace is calling your name, kick back and let that candle's glow fade away. Surrender to the softness of the remaining warmth. As the fire continues to watch over you, its presence never really gone. So as you nestle into your dreams, remember that gentle flame is there, patiently waiting for your return in the morning light. Good night, dear stargazer, rest well, and don't forget the universe is just a flicker away, keeping the warmth alive until you rise again.